Manas,
Yes, sir.
session 3 will basically I will mail to you.
What, sir?
Session 3 PPTs mail to you.
Okay, okay, sir. Okay.
Forward to them. Sir, good morning, sir. Sir, am I audible? Sir, am I audible? Audible, sir. Will start, sir. Audible, sir.
Yeah,
Will start, sir.
yeah, let's start.
Good morning to all, and welcome back to FDP and Data Sciences third day. FDP and Data Sciences third day.
Sir, some echo is coming.
Yes, some echo is coming. Yes. Now it's okay. Today we have a eminent resource person. Professor R.B.V. Subramaniam, NIT Varangal. Without delay, we will invite the resource person. I'm inviting physics scholar Manas Rahman to welcome the resource person.
Okay, thank you, sir. So, good morning, Mahendra. It is my immense pleasure to introduce our today's resource person, Professor R.B.V. Subramaniam, Professor, Department of Computer Science and Engineering, and Chief Investigator, Electronics and ICT Academy, National Institute of Technology, Telangana. His areas of research includes data mining, big data analysis, distributed data mining, graph databases, fuzzy data mining. Sir did both MTech and PhD from IIT Kharagpur. He is one of the senior member in IEEE and associate member in IEI. He published many papers in international journals and conferences. Till date, he supervised 8 students towards the successful completion of research, and few more students are currently working under his guidelines. Also, he organized several conferences and workshops. Today, he will be covering many topics and more knowledge. Be interactive and grab knowledge from him. Now, I would like to welcome Professor R.B.V. Subramanian sir to start the session. Sir, please.
Okay, thank you for introducing me. Sorry for the late. There was some power problem and then internet problem. Yeah, glad that Dr. Kumar got this ATAL program and he has scheduled the topics, and I hope in the last 2 days the participants have benefited out of the lectures. Today I am asked to introduce the problem of classification and then discuss some of the approaches to solve it, and later on to focus upon the problem of dimensional reduction. Yeah, some of the speakers handled yesterday, so of course interacted with me, and we often observing that the people are trying to use different techniques, knowing or unknowingly whether it is applicable to the problem what they are handling. It is happening because theoretical underpinnings are not much clear to the audience. That's how if someone uses one method, others think that that can be used anywhere and everywhere. This area, of course, though it is a bit old, nowadays it has gained much importance. The area we are talking now is machine learning. Making the machines to learn. Hence, how we can make the machines to learn. We are human beings, we can make the machines to learn like humans. Okay. Hence, the goal of any topic in machine learning is to make the machines to learn like humans. That is the very first attempt. That's why people have really focused how to make the machines to learn like humans. Now, any learning basically starts with thinking about the objects corresponding to that domain. Therefore, the agents which can think like humans are formulated, designed, and they all can be mapped to this quadrant. Then slowly, the human thinking is not something fixed. It is evolving and it changes human to a human. Therefore, is it possible to see that the approach is optimal? Since the next question was how to design the systems which can think optimally. Since thinking optimally is the desired feature. Now, once upon thinking and getting knowledge about the objects surrounding me, I would like to handle them. I would like to use them for my own comfort. Therefore, I would like to perform some actions. Since when it comes to performing or acting, again there will be two kinds. One is act like humans, performing optimally. And now I think you can figure out the goal of machine learning or AI is how do we design the systems which can think optimally and act optimally. Means thinking optimally and then upon the decision, acting optimally is the goal of any AI system in general, and more particularly machine learning focuses upon the thinking and the decision making process, leaving certain things to perform to the outer part of the ML but within the AI. Because for performing something we need certain abilities. Suppose I want to lift something here and put there, I should have the hands to lift it and I should be able to move carrying it, and then we have to put there. Since it requires certain abilities for me, and those things will be the outer part of the machine learning AI. Thus, the course is developed getting the source from the human thinking, human acting, and going little beyond how to outperform any human being. In this attempt, people were successful in making the machines to learn and perform certain tasks. The tasks particularly, we perform it, and if I see how you are performing, if I measure it, if I measure the way that you are performing the task, and the task performance will improve with experience. With experience. Since you can take several examples. You are driving, you are cooking, swimming. Since many such tasks, you will improve it. You will be performing it in a better and better manner as you gain more and more experience. Okay. Hence, here with experience, we will perform it in a better way. Now, what do you mean by experience? Hence, mostly if I ask what is your experience, of course, some people will answer in one way, that they have some 10 years experience, 20 years experience. Others will say that, okay, I went to some place, my experiences are like this. Means experience is the word which generally people take in these two directions. Hence here now what do you mean by, in the context of the machine learning, what do you mean by a particular algorithm which you have written to perform a task uh, performs in a better manner with more and more experience. What do you mean by algorithm is getting experience? Does it mean that if you run the algorithm for many times, for many years, will it work fine or something else? Hence here we have to understand either it is in experience in 10 years or your experience of visiting the places. The point is you are narrating in terms of experience that your exposure to the objects. Hence, in the name of experience, you are exposing, you are getting exposure to various objects. As you see more and more objects in your concerned domain, then your familiarity, your knowledge, and the requisite skills to perform the task will also be improving. That's the point. Suppose you are a good psychologist who can assess the other person in 5 minutes talk. How you got, just by talking for 5 minutes, how you are able to assess the other person? It is because we have developed the talk by interacting with many people. It is not the question of your 10 year or 5 year. It may be sometimes you may pick it up in 2 years. But it matters that how many people with whom you have uh, uh, interacted, and then you have applied your brain in understanding the human psychology. Is it not? Therefore, here the experience is always in terms of the objects. Since now when it comes to the objects, we are introducing the objects to the machine. You see, we are also see our parents, peers, friends, teachers, they help us to understand this world, is it not? Hence, your mother perhaps introduced several objects in your home, vegetables, fruits, and other toys, and all the other goods in your house. Who has introduced you? Your own family members have introduced. Thereby, you got what is what and with what you can do. Hence, you got familiarity with those objects. Similarly, when you step out into the society, there are many others for helping you to understand the worldly objects. Hence, this knowledge about the worldly objects is very much required when you want to live here in this society. That's the point. Hence, how a particular object is introduced to you. Suppose you take any object, say for example, some fruit or vegetable. Then your mother may be asking you to look at that particular fruit. You may be asking you to look at the shape of the vegetable, uh, taste of the vegetable, and the color of the vegetable. These are certain things which you are considering as features. Hence, these are called features. Hence, your mother would like to introduce this object in terms of the features, shape, taste, color, and so on. Hence, this particular object may be having some specific shape, some specific taste, some color, red color, something like this. Hence, these are the values of this object for the features. And these vegetables, which we know, which we have been using in our lives, are already given some names. Is it not? And something is called tomato, some fruit is called apple. And so suppose this object name is tomato, then what I am writing here is the name of the object. That is the class to which this object belongs to. Since this object is already labeled, given certain label, what we call it as class label. Since what I have considered is labeled objects. Means now I'm focusing upon the labeled objects and trying to introduce these labeled objects to a human being and parallelly to a mission. Since now your mother has taken another object and she introduced that particular object also through these features and its classmates. Maybe this is what we call the potato. Okay, things like this, you are exposed to various objects, now this way, your mother is helping you to understand the fruits and vegetables. Thereby, you came to know about these labeled objects. You have got the knowledge about the objects. Then with this knowledge, you can try to live in the society as far as the vegetables and fruits are concerned. Suppose you want something, you will go to a market and you will ask, I want a potato, I want tomato, I want drumstick, something like that, or some apple, this kind of thing, and then they will. Hence, the names given to this object should be known to you because you cannot give your own name. You have to call with the name that the society is calling you. And sometimes your mother may test you whether you have got the knowledge rightly or not. Then what she will do, she will ask you to name any object. And she is showing you one object X. Showing you means you are able to extract the features, you are able to see the features, what is shape, what is taste and color, so on. Since the values of the new object X is given, and but only the question is, so far during training period, she used to tell the class label. Since this was training period, And now in a file testing, what is happening? Now here the X object is shown, its values of the features are given, but what is not given is the label of the object. Class of the object is not given. Since now what is your question? Your examination is you have to specify the class. Since specify the class to which this object X belongs to. Specify the class of X. Then specifying the class of X is called classifying. Hence, when I say classify X, it means specify the class of X. Specify the class of X. Hence, the task what I am telling now is classify the objects. Classify the objects is the task. Hence, in this task, like drive, cook, swim. Similarly, I am asking you, come on, classify. Hence, classify is a task which I am expecting the mission to perform. And what it will do in the name of this task, it is going to specify the class. Hence, what is the answer? Answer is one of these classes. Yes, you know certain 10,000 fruits and 10,000 vegetables, suppose. Then your answer will be, since totally in this training period, you have exposed to certain number of classes, C1, C2, C1. This will be C2, this will be C4, this is something like this. Since there are so many classes, hence I am calling it as C1, C2, C1. Hence, answer will be one of those C1, C2, C1. Hence, the answer is one of the C1, C2, C. That is the answer for this. Okay. Hence, how do you specify this one of the C1, C2, Cm upon seeing the X? This is the capability of the mission to perform the task. Okay. And now, here, now what do you mean by the experience? Since experience means, say suppose you see only 10 vegetables, will you get that capability of naming any vegetables or fruit on this earth? No, since it requires lot of exposure to various vegetables and fruits. If you have seen more and more vegetables and more fruits, then only you will be the person who can name a vegetable or fruit on this earth. Hence, this we have improved with your exposure to the vegetables. Not in terms of yes, some people may live in some small village where they have limited exposure to only certain vegetables and fruits, and they may have some 20 years, 30 years living in that particular area. But you are a person, suppose you are moving across the globe and knowing various vegetables in Africa, America, and so on, you are the person having that. Since it is not the question of in terms of years, it is the number of objects that we have seen. Hence, in the training period, in the exposure, in the training, how many objects that we have seen matters. That matters. Therefore, for each object, there is some tuple in this training data. Since when I say experience means as you see more and more data. Hence, this is the number of objects, that is for each object we have this, is the data. And the question is, experience means here the exposure to the data. Hence, as you see more and more data, the way you perform the task will also be in a better and better manner. That's why the machine learning, the data science, everywhere, why you talk about the data? Because data is the feeding for this algorithm. As you do more and more data, your algorithm performance will be better and better because it is learning from data. It is learning from data. We are also learning from exposure to the object. That's how we introduce the objects to the mission in this manner. Okay. If you are successful in introducing the concerned world and objects of some specific world, then if it can pick it up the performing the task, then mission will do wonders. That's what happening. Hence, therefore, certain in some problems, we are able to introduce the objects to the mission successfully, or even the steps which that particular task doing, if you can explicitly write in a proper manner, then definitely system is doing that. And suppose you want to multiply to masses, you can very explicitly you can express in a formal manner the steps with which the matrix multiplication is happening. Then the system is performing multiplication of two masses of any size, say 10,000 by 10,000. If you can write a really good algorithm, and then definitely it is performing better than a human being. For human being, it takes time to multiply even 100 by 100 size two masses, but for the system it is just a cakewalk. But there are certain tasks like recognizing the human beings, understanding the voice. You know, the other side, Dr. Kumar is talking. How I recognize him after a long time. Hence, how do I recognize his face? Okay, these are all certain tasks. Human beings are performing better, not the machines. Then what? Where is fault? Is that mission which is doing in a better manner in matrix multiplication or some other problems, why it is not doing even at least as like a human being in some other task? It is not the problem with the mission. It is the problem that we are failing to introduce that concerned world. Those objects or the procedure we are unable to formally represent. Therefore, once if you are successful, definitely mission will outperform the human being. That's why in my earlier programs, that sometimes certain tasks, the missions are beating the human. Since we started missions to learn like humans and would like to see that the missions um, perform beyond the capabilities of the human thinking and human acting. That's the okay. Hence, that's how we can consider several tasks, and we can see that mission always learn from the data and then perform the task. This is how several tasks are going to be considered in this FDP, and the approaches uh, here. Approach means what? The approach should be how it learns from this data. So, okay, given the data, how it learns from the data. Hence, what it is learning, how it is learning. Upon learning, how it is being used. These are the three things that we have to focus upon. Okay, hence now, given the data, what it learns and how that learning is being used to specify the class. Similarly, for any other problem, this is the way that you have to attack any topic in the dictionary. Okay, now I will be focusing only on this classification, which is useful to classify the objects. Hence, classification is useful to classify the objects. Classifying the objects means specifying the class. Yes, that is the task which I would like to focus upon today. Okay. Yeah. Yeah. Any sometimes you can stop me and then we discuss. Yeah. Any discussion? Any doubt so far? Now I will be introducing. Now I have said that the problem of classification is specifying the class of the given object. How do you specify the class? Only if you know the classes of various objects. How you came to know that happened during training period. Hence, we assume that there is a training about the labeled objects. The data is given. It is of this form. Hence, training data is nothing but for various objects, we note down the values of the features as well as the class label. This is the training data. Given the training data, learn from it. But how do you learn? That's what I am going to tell. Hence, learning from this, you have to, and what you are going to learn, how you will learn. These are the two things which you will be focusing. Once if you are successful, then once you have learned, you got the knowledge, use it to specify the class. That is your performing the task. This is the high level problem where I am going down into the details how we perform each and every thing. Okay. Yeah. Any discussion or any doubt here? You can unmute yourself and ask, or put it in the chatting. We'll do it.
Participants, please interact if you have any doubt, or
Please
else
interact if you have any doubt,
or else message in chat box.
message in chat box. something was about echo. I think not, that problem is already solved.
Yes, sir. Sir. Yes, sir.
Yeah. Someone was talking. Okay. Okay. Let me continue. Or maybe sometime later we will get some point. Yeah. Okay. I use the word called knowledge. Hence, okay, what you will learn? Sir, the goal of my learning is to have knowledge. Hence, what you want to learn? I want to learn, get the knowledge. You want knowledge. Now, what do you mean by knowledge? How to gain it from this data? Hence, the assumption is this data contains knowledge. Is it? Yeah. Hence, that's how certain words are there loosely. Since we have the word data, I have used it. Hence, if someone tells what is the data, data is plural, but generally we use what is data because data is singular, but no one uses that way. Hence, now what is data according to any person you can name, someone can tell what is data. Since I want to learn and get the knowledge, is it not? Now these words are there, data is there, sometimes you perhaps use the word information, knowledge. Someone can you relate these three words? Because already 2 days over election.
Good morning, sir. Data is raw data.
Good morning, sir. Data is raw data.
Processed
No, data, raw
data
data,
is
no.
not.
I am defining data.
Data is
Okay.
Sir, some messages here in chat box.
some messages here in chat box.
Facts and figures.
Yeah.
Facts and figures.
Facts and figures. Okay. Hence, data is collection of facts, okay, and figures, of course, we use the word. Hence, yes, the color of the object is a fact. Taste is a fact. Shape is a fact. Hence, I have taken facts about this entity. Hence, facts about entities are being taken. Therefore, this is data. I have taken data of another object, that is facts about this second object. Hence, facts about your height is a fact, your weight is a fact, your specialization is a fact, your degree is a fact. Hence, when I am saying that, the feature values are nothing but the data. Hence, therefore, what I have taken is data. Okay. Now, this data holds the information about the objects. Hence, when you want to say, suppose I want to know about you, I will ask you, please inform about you. Then you will start that, okay, I have studied my UZ, my interesting topics are this, I have been doing research in this, I have this, I have that, and so on. You are telling the features about yourself you are interested. It means the values, the facts which are about you, or if I put them there, and that data contains the information about you. Therefore, information only is stored by means of data. And if you process the data, you will get back the information. This is how no author would like to convey some information. Is what author is doing. Author is whatever he wants to convey that information. He is writing in terms of words and sentences, character data, and typing or printing, and the book is ready. Okay. Hence, the character data in the book holds the information. Hence, author has put the information in the data and you are reading the data and getting back that information. Hence, several courses in computer science focused upon how do you store information in terms of data and how do you process this data to get back the information. This interplay between the information and data has been of interest for many years when we are growing our computer science. Later on, people have focused. Is that only always we are have some information that I want to store it by means of data and process the data and get back the information is the only play possible, or is it the way that human beings are doing? Then we started thinking, people started thinking that suppose author has some information, author has some information. And therefore, what author is doing? Author is writing a book, and thereby you have the data, character data in the book. Okay. Now you are a reader, you are reading it, and getting that information from the book. Hence, you are reading the data in the book and getting the information. Okay, fine. Now, again, that information which you have extracted from the book, you would like to store it in your mind. Hence, in your memory, you are storing this information once again. Hence, in your memory, the information is again converted to data. Hence, in your memory, this is in the book, and now this is in your memory. You have extracted information, author has stored it, and you have extracted, and again you have coded it in the form of data. Hence, in the memory, you have this data. Now you imagine, is that the data in your memory and data in the book are the same? Hence, upon reading one book, do you agree that the entire data I have processed, took the information out, and then again stored in my mind, and in my mind I have data, in the book I have data, are they same? Then we won't agree. No, sir, not that entire data is not there in your mind. Then what is there in your mind? What you have extracted. Hence, if in the name of reading, understanding, assimilating, whatever it may be, what you have extracted, and that extracted one you have stored in your memory, what is being stored? These are the two things to see. Then people that, oh, human beings, when we look at the data, we are doing something different. What that you are extracting, what that you are storing in your memory. These are very two interesting issues raised at a later stage. Then people have called this, oh, would like to call it as knowledge. Hence, we are discovering the knowledge from the data. Hence, knowledge discovery is the basic process that the human beings are doing. Hence, when I am looking at some objects, when I am studying something, when I am observing something, always my goal is to discover the knowledge about those objects. Okay. Therefore, what is this knowledge? Hence, if I say, suppose you have knowledge to reach knowledge about the route path from Kasaragod to Hyderabad, then you know Kasaragod is there and there are multiple ways of reaching Hyderabad. You can come via some way or the other. Then it means that you have this. How do you remember this? How in fact it is there in your mind? In what way? What way? Simple thing. You quite daily you move from your house, from the village to your college in nearby town. Hence, how do you remember the path from your house to the college? which is suppose let us say 5 kilometers away. Yes, then you will say that I know the path. Yeah, no, no. You tell me what is there in your mind regarding this path from your house to the college. Then you will say, sir, if I imagine it, my the content in my mind is something like this. I will come out of the my village. There are paddy fields. Just after crossing paddy fields, we see one big water tank and this big lake kind of thing. And after crossing the lake, a small forest area, small area, and after that there will be some industrial area, and then we enter into one colony. After crossing a housing complex colony, we enter into our academic. Oh, good. Means you are remembering this way that it is the paddy fields and then lake and then the forest, then the industrial area, then some housing colony, then your colonies. These colonies. Hence colony here and the industrial area here, the forest here, the lake here, the paddy fields. You are not remembering like in the Google, no? You take 2 kilometers, then take 90 degrees turn. No, you are remembering this. It is in terms of patterns. This is what we say. Hence, paddy fields their pattern. Once that is over, then the water lake pattern, then forest pattern, then industry. Hence, when you are traveling this, you have picked up this pattern, and this pattern only there in your mind. Hence, when you are studying this data also, you are extracting those patterns. And those patterns only stored in your mind. Hence, when I am talking it, what is there in my mind? I have patterns which I have extracted maybe during my study time. I have extracted them. Those patterns are there in my mind. Depending upon the time given to me, I manage the patterns, I express them with my capability of communication. Thereby people say, okay, this fellow has some knowledge about this topic. Yes, the patterns are there in my mind. It is not the same data what is there in the textbook. Since from the data I have extracted patterns and I have stored those patterns and I am using them to express through my capability of communication. Hence, this knowledge basically is the interpretation of the patterns. Hence, if you want to have the knowledge, the key point is you extract the patterns. Now, what is a pattern? Okay, sir, you said that we are convinced knowledge is interpretation of patterns. Hence, therefore, we have to extract patterns. This you will definitely look at it, particularly in the examination. Most of you perhaps experience. Sometimes, no, we will struggle to recollect something. And if I ask what you are struggling, yeah, I know I'm just forget about the last 2 lines of the previous page. I remember what is there in the first line of the next page, and somehow I'm able to recollect last 2 lines of the previous page. So you know the location of the content, may not be page number, you may not remember. You know that page as it is, that 2 page, that something is there in your mind, and you are trying. After struggling, maybe after 5 minutes, suddenly, yeah, you got it. Then you will start writing. Yeah, now I got it, I am writing. Okay, if I see what we have written, that and the last 2 lines of the previous page, is it the same words? No. Meaning of the words in the last 2 lines, the meaning of the words what we have written on the answer script, both are same, but not the exact words. It means what is there in your mind about the last 2 lines and why those words only not coming. Means is that these words went into your mind? No. Then what entered into your mind? And why you are writing some other words here? It means you have extracted patterns. You have understood and you have extracted patterns. And the patterns are interpreted in the end. Okay. Just therefore, it means what happened? The pattern corresponding to the last two lines is somewhere in depth. His previous pattern you remember and afterwards you remember. Sometimes you forget this. There is something between the lake and the industry area. What is that? A forest? No? That particular thing is missing. Hence, always when you look at something, when you trying to understand, if you have understood means in your memory, if you feel you have everything in terms of patterns, in terms of. Therefore, human way of learning from the data, from the objects, it is just you always like to extract the pattern. Hence, from this data also, I want to extract the patterns. Hence now one question is answered. Hence in the name of learning, what you want to learn? I want to learn the patterns. Because those patterns, if I interpret them, they give the requisite knowledge to specify the class. Hence, this task doing requires some knowledge. That knowledge is there in this data. Is therefore, how do I get the knowledge? Knowledge you won't be get directly. First we have to extract patterns. Hence, in the name of learning, what you want to do, you want to take the patterns out, extract patterns from the data. Hence, in machine learning, in the name of learning, what we do, we will extract the patterns. Pattern extraction is the main key. Okay. Now, once patterns are extracted, these patterns sometimes they form some cohesive structure. Cohesive structure. These patterns, no, when you put them, they may formulate, they may get into some kind of structure. That structure may be apparent to you, may not be apparent to you. Because there will be some logical structures. But it is a structure. It may not be seen. There may be some physical kind of. See, what is this room? This room is made up of bricks and this. Hence, how this structure has got. I have arranged the bricks in one particular form, therefore I got one particular shape of the room. Is it not? The structure is in fact the arrangement of these patterns. Hence, the patterns when I am extracting, if they get into some shape, that form, the structure means that structure of patterns. That's what I can call it as the model. Hence, generally people use this word. People nowadays are not using this word pattern extraction. Mostly people say that in the name of learning, we build models. Basically, what a model consists of? Model is embodiment of patterns. Hence, you are basically when you want to build a model, you are trying to extract patterns, and the patterns they are forming some kind of structure. If it is an apparent structure, suppose something like this, suppose this way, and if I combine these three, what I will get? 1, 2, this is 1, this is 2. Now I have combined 1 and 2 over. Now the third one I am bringing and then putting. Hence 1 is there, 2 is there, third one is there. Hence the third one, 1, 2, 3. Hence this is third one. Hence since I have got an apparent structure. Hence there are 3 patterns. The embodiment is of this kind. Hence we say it is a model. Since I may have certain nodes here, I may have the nodes, suppose like this. Oh, there are 3 kind of structures. Yeah, basically it consists of 3 patterns. This is I am calling it as model. Therefore, when you say that sir, in machine learning, we learn and build a model. Yeah, you learn, build a model, but how a model is formulated? Basically, pattern. Hence, very primitive operation here is extracting pattern. Okay. And the patterns they are forming a model. Therefore, the goal of machine learning algorithm here is build a model by extracting pattern. And that model is being used to specify the class or whatever the class. Okay. I hope the words model, pattern, knowledge, data, information is clear to you. But what do you mean by pattern? That I'm yet to clear. Hence, pattern is how to define pattern. Now you say paddy fields is a pattern, lake is a pattern. What do you mean by that? Forest is a pattern. Forest means there are trees. In your academic complex also there are trees. Do you want to call your college as forest? Oh, no, sir. Yeah. Then why you call the trees there? Not here also trees are there. No, predominant objects are trees there. Because in forest there will be rock, there will be snake, there will be some fox also may be there. But still the predominant objects is trees. There will be several kinds of trees. So neem tree, there may be some other sandalwood tree, there are so many kinds.
Sir, sorry to interrupt you, sir.
But in general, the predominant objects are trees. Hello?
I have a small query here, sir. Can I ask, sir?
Yeah, please.
Sir, actually, you are telling that the model is nothing but pattern. So that means
Embodiment,
each data will be framing a model, right?
From data, you are building a model.
Yes, sir. So, but in machine learning, we are having a lot of models, sir. So, we are changing the native state of that. For example, like ANN or some other some SVM or something. So, we are changing the native state of the model, or whether we are using that model to get insights from the data, sir. Will you please explain it, sir? Thank you.
Yeah. Good question. Now, see, SVM is an approach. Neural network is another approach. Hence, these approaches you are applying on data, and each approach will give you a model. Each approach gives a model. And I said that model consists of patterns. Hence, neural networks learning helps you to extract patterns out of the data and gives the model. Hence, model is the resultant of the approach, and model consists of patterns. The source is data, approach is neural network, answer is the model. Model consists of patterns. The model is useful to solve the problem. What is that problem? Classifying the objects. SVM. SVM is another approach. The same data is the feed, that is the source. Approach is now different, but the model ultimately, that is also again C. Model, which consists of the patterns, useful for solving that problem, again C. Hence now approaches are different. It may be SVM, it may be this, that. The data is same and the model is same. The model consists of the patterns, and those patterns only you use them. Okay, that's how we get it. Hence, we are moving from one approach to another approach. It's not just I'm changing the model. No, I'm not changing the model. I'm changing from one approach to another approach. Why you feel another approach is better? That approach may be easy to extract patterns from so and so data. Maybe another approach is not that good. Hence, you have chosen some approach, or you have designed some approach algorithm so that it extracts patterns from the data. That's it. Okay. Hence, different models are obtained because of different approaches. That's how you feel that. But the data is same, ultimately the knowledge is also same. Knowledge is also same. The knowledge only is being used to solve the problem. That's it. Okay. Okay. I hope that answers. Slowly we will come to know something. Hence, each such, say for example, you have these points. In fact, these are all the objects. These are all the objects. Maybe these are girls in the classroom, these are boys in the classroom. Somehow, when I asked them, they have occupied the positions in the garden. They sat like this. Now, what we do? Now we want to build apply SVM. SVM in the name of SVM. That is an approach. I'm not changing model. I'm taking the data. Now my approach is what I will do. I will try to fit a line. So that this line is acting as separation between two classes, girls from boys. Hence, if you take an object which is right to this particular line, then it is class 1, otherwise class 2. Hence, how do I fit this line? Why should I put it here only? Why not you put in this place? Why not at this place? Why not this way? Why not this way? Hence, there are so many positions where I can fix this line. Hence, all your SVM approach is telling you how to fix the line. Once the line is there, now this separation of this line, this is what we call linearly separable. You are fixing with the line, and these vectors which are close to this, since these are far away, these are close to this line of separation. These points, these data points, these objects are called support vectors. And we have to fix the line appropriately so that the optimum distance is there from the support vector. Since the approach explains some way of constructing this line of separation, if not line, non-linear kind, if not two-class, multi-class. Since you are applying this SVM to multiple types of problems of classification, but here the approach tells you, you construct it, and this is separating one class from the other. Okay. Hence, approach is different. Data is same. And the approach gives you something, and that something you are using so that given the object, okay, I will give you an object, and that object goes and sit here. Oh, since it is sitting on the right side, it is called class 1. If it is sitting on the left side, it is maybe the class 2. Like this we use. Okay. And same thing with the same data, if I give it to a neural network, it learns. It learns again. How you learn it? Again, there is an approach that given the data of each object, once this object is given, how it learning from these features, how it will pronounce it as a tomato. Hence your output node, all
Sir, sorry to
neurons
interrupt,
in the
sir. A
output
small
layer should
more
be,
clarification.
yeah.
So, sir, as it like the end product is the model, sir. After classification and recognition of this, the end product is model, am I right, sir?
Yeah, end product of an approach is model.
Okay, thank you, sir.
Sir, Subramanian, sir. Whenever participants
Yeah.
speak, echo is coming. Is it possible to adjust your
Participants,
speaking time? Echo is coming. Two times echo is coming. Two times.
no, what you are talking is not clear. Please repeat, Kumar.
Sir, echo is coming. Sir, echo is coming. Two
Echo.
times. Yes, sir. Two times. Yes, sir.
Now,
Now, okay, sir. Yes, sir. Now, sir, two times.
yeah. See, echo comes when someone yeah, if someone put it on. Now, suppose if you put it on, my voice coming out of your system, no, again it will enter into that.
Yes, sir.
Echo comes from the respective places.
For us, it is audibility. From while teaching, no problem. So, participants talking time.
Yeah. Okay. If all the mics are on mute, only if my mic is working, then generally there will not be an echo. Fine. Since we are designing the machine learning algorithms approaches, which will extract patterns and formulate the model. And that model will use it. Okay. Now you have said certain approaches, neural network, SVM, and I may discuss some other kind also, because I am asked to give lecture on decision trees. Let me mold it according to that. Hence, from this data, I want to extract patterns. Okay, but I don't know what patterns are to be extracted. First of all, what do you mean by pattern? I was trying to explain it, but meantime this question has come. Since pattern is collection of similar objects. In the forest, majority predominant objects are trees. Paddy fields, there may be some other kind of small crop may be there, but the majority of the crop is paddy. Lake, it is a water body. Industrial area, there are buildings, they're all meant for industry. Housing colony, and something like this is this collection of similar objects. That's what we are calling pattern. Hence now here also we have to extract objects which are similar and consider it as a pattern and store them. That's fine. Hence objects belonging to multiple classes are being stored. Hence what is this data? Tomatoes are there, potatoes are there, apples are there. Hence information about various fruits and vegetables are in this data. Now you have to take that out. This data is in fact collection of various objects belonging to various classes. Hence, objects belonging to multiple classes are in this data. Hence, what is problem here? Can someone tell what is the problem with this data? It's very foolish questions for someone. What is the problem with data? Means there is no problems are for data. Data is data only. No, that is not the answer. I'm repeatedly asking this question. Maybe for 2 hours, if you spend like this, slowly then you may understand what I want from you. Hence, what is that? I have already described something, that this data is about the objects. Objects belong to various classes. Therefore, what do you see? If I ask you, you complain something on this, you describe this data, what you want to tell about this? You tell whatever you like. See, that when you say that question is a very baseless, foolish kind of question, answer can also be like that. No problem, I take it. Anyone can tell. When I give you data, data is about the objects. Objects belong to various classes. Do you find any problem here?
Sir, missing values can be a problem with data, sir. And some
Okay,
data may be
okay.
imbalanced. So some
Imbalanced.
rescaling may be required. And these
Right,
missing
right,
values may be
okay.
dealt with the data imputation or data interpolation sort of techniques.
Right.
Okay, sir. And
Okay. Hence
yes,
now
thank you, sir.
you are looking from some angle. Hence now see, you are looking from some angle. Hence when I say someone, you tell me about the society. Yeah, society is full of, sir, all thieves are there, the people who deceive us, no, all are dangerous fellows, something, no. This is my understanding of my own society. Similarly here, no, you are right. All what you said are generally the problems that you may encounter in the data. Hence, when I give the data, there may be missing values. What do you mean by missing value? The color of this object somehow I have not filled. Or I will write it as some RAD. Then you can't understand what is this RAD. By mistake, RAD I have written as RAD. Hence now either value is missing or there is an error. Suppose now I am writing the length of that. Hence height of any student should be from one, say suppose your BTech class, it may be from 100 centimeter to maximum 200 centimeter. Suppose I say 1500 centimeter. 1500 centimeter student will not be there in your class. Hence it is something error, sudden upsurge. This kind of problems may be there for the data. And there is, you have used one word, imbalance. Imbalance means there are two classes, say for example. Majority of the objects belong to same class and there is minority of the objects. Hence in the society also there will be some majority class and minority class. Say suppose you take the cancer patients. Hence in any town, the number of cancer patients are very less, maybe just in terms of tens. But thousands, lakhs of people are non-cancer. Hence, majority belong to non-cancer, minority belongs to cancer. Hence, when I am taking the data of those people, definitely it is an imbalance case. This kind of problems will be there, I agree. That is, hence each such problem has its own solution. and I'm not expecting that as the answer. Okay, thank you for your description. It's good. We have answers for those questions also. Hence, how to see that the missing values are not there. Hence, let us assume that there are no missing values. There's nothing like one class is dominating. There's no imbalance among the classes. All the classes are balanced, more or less same number. Good representation is there for each class. Then, still, is there any problem with this data? Someone else. Yeah. Now, come on, think. Anyone else?
You can send messages also. You can send messages also.
No? Yeah. My answer is very simple. I have already put my answer in the question itself. What I have taken objects belonging to various classes. It means what I have taken is a mixture of the. Oh, this is very foolish answer, sir. Yeah, I said my question is also foolish. The answer is foolish. Hence, mixture of the objects. I have taken the objects, tomatoes I have taken, potatoes I have taken, I have all mixed up. Hence, the data what I gave you is a mixture. Hence, your mother, she is a good teacher. That's why we say always our parents are not first teachers, best teachers. Without creating any confusion in your mind, your mother has introduced one vegetable after the other, and slowly, without any confusion, very good knowledge is there in your mind about vegetables. Later on, there are so many teachers, they have confused you. They could not put you nicely. I am also a teacher now. I am putting lot of confusion in your mind. But your mother was not like me. She nicely explained it. Unfortunately, here also what is happening? I have not given tomatoes separately, potatoes. I have mixed up. It is something like the olden days. No, even now people who take a bag to a market and they bring all vegetables. And if you see the bag is the mixture of so many items, fruits and vegetables. Now what we do? After coming home, we segregate them separately. Hence, the problem with this data is the mixture. Very simple problem. Okay. Do you agree? Is it a mixture or not? Is it a mixture or not? Since once if you can understand this very keenly, the answer may be very silly, but the whole machine learning problems, all problems what you are attacking is same thing, mixture only. We are all considering the mixture problems. Hence, I have taken a mixture. Do you agree that mixture is a problem here? The person who was speaking nicely, he has some good knowledge about this, has left. Oh, Jagdish Kumar left. Okay, fine. Is it a mixture? Can someone answer? Now, what is problem with the mixer? Now I say the problem is mixer. Okay, so what? Okay, mixer is given to you. What is the problem? If you have problem with the mixer, how to come out of it? Demix it. Demix it. If there is some problem with the mixer, you demix it. Demix means segregate it. If you demix, the problem with the mixer will disappear. If any problem arises because of the mixer, should go the moment I demix it. Hence, now we will discuss how to demix it. That's why I am asking first of all. You all have to notice and understand. Oh, it is a mixer problems are okay. If mixer is a problem, how to overcome it? Demix it. If you are not convinced that it is a mixer problem, then we have to debate something on this, and then we have to think of whether it is a right description of the problem or not. Then we have to think. That's why I'm asking you, are you got convinced that the problem is a mixer problem? Is there anyone who is looking at it? Can someone respond?
Participants, you can express your views. Participants, you can express your views.
One by one, చలికి మార్నింగ్ కార్యక్రమం ఎక్కువ మార్నింగ్ ఎక్స్పోజర్ yeah. Okay. Now this yes, I don't know, is yes for the audio problem or yes for my question mixer?
Hello. Sorry.
Yeah.
Hello. Sorry
Yeah,
to
Neetu
interrupt you, sir.
Chauhan.
But yes, sir. Actually, I could not get the last few minutes of your audio. So when you started talking about this mixture problem, I was not able to hear you properly.
Yeah. Now my point is, I have taken some data of the objects belonging to various classes. Can I call it as a mixer problem? It is a mixture of objects, is it not?
Yes, yes, sir. It's a mixture of objects.
Yes, sir. It's a mixture of objects.
Yes, yeah. I consider that it as a problem. Since it is all mixed up, I feel that if I demix it, my confusion, my inability to understand these objects because they are mixed up, if I segregate it, maybe I will get some clarity on the objects. Therefore, I prefer to demix it. Okay? Just I'm throwing some stone because I don't know what to do with this data. I have considered this data, oh, this is a mixture. Hence, in the mixed form, I can't get anything. Hence, therefore, let me demix it. That is initially just an attacking. I don't know what it is going to lead, but let me demix it. Because why you are thinking? Yeah, my goal is extracting patterns. And my understanding pattern means collection of similar things. Hence, when one set of objects which are similar, which I would like to call it as a pattern, this pattern, collection of another similar objects, there is another pattern. All these patterns are mixed up here. Therefore, when I want to extract the patterns, this mixer should be demixed. That is the origin of my idea. Therefore, I consider this data as a mixer problem and I would like to demix it. When I say, come on, demix it, like you take the example of the vegetables and fruits you brought in a bag and you start demixing, how you will demix it?
So based on the similarities
So based on the
of the
similarities
objects,
of the objects,
By
No.
data sorting,
Fine.
cleaning data is already there.
Sorting.
It's not based on machine learning. Pre-processing of the data.
Yeah. Fine.
Automatically, these R and Python, when you use, there are, it will flag no, sir. Like there is some error in the data or something like that. Unless we deliberately take it as the label.
Right. Wait, the problem now here, now see, when we are attacking some, no, people have to think only on that question. Particularly for the research issues and research talk or for understanding its evolution, we should not get deviated. The problem here, did I say that there is some error in the data, there are missing values? Did I say that? No. And now, pre-processing is required to cleanse the data, to remove the errors, all these things. But I never said that my data contains the errors and all. And so let us not bother about some pre-processing is required, R will do, Python will do. I don't know the R and Python. How I am designing an approach, how I will solve the problem. The problem is specifying the class of the given object. For that, some knowledge is required. The knowledge requires nothing but patterns. The patterns are all, patterns means each pattern is a collection of similar objects. Hence, each pattern is a collection of similar objects, and those patterns are all mixed up. Tomato pattern, potato pattern, all are mixed up. Therefore, I have taken as a mixture, I am demixing. This demixing can't be obtained just because of pre-processing. Vegetables and fruits from the market. Now, how do you segregate it? Demixing means that mixer you have to demix, no? Hence, how you will do? This is a very simple question. You have to think only on this. Hence, don't bring something else which we are not at all talking. Hence, now here, how you will mix it? Suppose you give this task to a child. Suppose now all the vegetables are poured on the ground. A child, what she will do? She may look at one feature, color, red colored objects she will put in one, green in another, yellow, hence all red color, green, yellow, like this, remixing. Hence when I say, when you brought the objects and you are segregating, you may be segregating, demixing, maybe on color, or maybe on shape. Yes, this is what the child is going to do. Is it not? That's all. Very simple thing I am asking. You will be taking one of these features, maybe looking at the shape. Oh, all these are same shape. You put here. This is a different shape. You put in other. It is based on the shape, or based on the taste, or based on the color. Things like this. There are so many features, n features are there. You may be taking one feature and then demixing. Is it okay?
Yes, sir.
Do you agree with that?
Yes, sir.
Yes, sir.
Hence, it is a very natural answer. See, what I am asking, question is very simple question, and I am asking, expecting very natural answer. Hence, the mixer is that what I am doing, demixing. For demixing, I have chosen shape. Or if I give this problem to you, you may don't want to separate first on shape. You may separate on color. Hence, if you start demixing on color, what is the output? All red colored into one group, yellow, blue, something like this, green. Hence, based on the color, you have segregated. Hence, this data, if you say D, originally D is divided into D1. D1 is all red colored objects, vegetables, fruits. Vegetables and fruits, what are they? D2 all yellow color, D3 blue, D4. Hence, D is segregated into, partitioned into, decomposed into D1, D2, D3, D4. You have separated on color. Somehow I didn't like that color. I want to separate on shape. Hence, I will take all S1 shape, it is spherical. I will put into S2 shape, because S1 is there and another S1 will be there. All S1 will be, all this S1 will go into this side. S2 will go here. S3. Hence this D1, D2, D3. Hence for D I got D1, D2, D3. For D you got D1, D2, D3, D4. Your D1 is different, my D1 is different. Your D1 is red colored objects, my D1 is S1 shape. Okay. This is how you start demixing. It's not ended. Only beginning of the demixing. Do you like this approach first? Let us start this way. Is it okay?
Yes, sir.
Yes, sir.
Right. Now the question is, once these are all separated, separated. Let us assume once the moment you separated all red colored objects, suppose they are all tomatoes. Let us assume there's no another red color object in your bag. Only red colored objects are just tomatoes. Whereas the green, it contains chili, is this D4. D4 contains chili, green apples, and some other green vegetables. Now you tell me, is this D1 a mixer or non-mixer? D1, which is red colored objects, I said they are all only tomatoes. Is it a mixer or non-mixer?
Sir,
Mixer or
non-mixture.
On the other
It's a
hand,
non-mixture.
non-mixer. And whereas here green color, there are chilies, green apples, and so on. Is it a mixer or non-mixer?
Sir, it's a mixture.
Sir, it's a mixture.
Mixer. When it is a mixer, still you have to segregate it. You have to still demix it.
Yes, sir.
Is it required or not?
Yes.
Yes, sir.
Required. Therefore, I
Yes.
will demix this D4, whereas I need not demix here this tomato because the all belong to same class or not. These objects all are tomatoes. All belong to same class. Oh, this particular container, because I am separating, no, I am putting in another basket. This basket contains only tomatoes. Hence, I got the knowledge. I have separated a set of similar objects. I have extracted a pattern. Over, completed. Hence, one particular channel, I have separated pattern. This need not be further demix it. Hence, demixing need not be done when you get a non-mixer. It's a non-mixer. No more demixing required. Whereas here, in the green color objects, it is still a mixer. Therefore, further demixing is required. On what basis? Maybe on taste you will demix it. On taste, if you demix it, then you may get D4 will become D41, D42, D4. Therefore, what happened? You started, I will put in the other way, let me draw. Hence, we have started with color. Color is chosen as a feature. And based on this feature, you have separated the objects, red, green, and so on. The red ones got into D1, but D1 is a non-mixer. This non-mixer, of course, when we look at it, they are all only tomatoes. Since it is a non-mixer, further demixing not required. Whereas in green, you have got D2, but this D2 is still a mixer. Is still a mixer. Therefore, you have to separate them. To separate it, what I have chosen, maybe the shape. Then I am separating S1, S3, S6. Three colors, three shapes are there. Then thereby I got D21, D22, D23. And suppose, fortunately, this is still a mixer. Then I may separate it on again demixing on paste. Whereas D22 suppose is a non-mixer. Non-mixer. Non-mixer means they all belong to the same class. What is that class? Maybe some C3. I will just put C3 here. No more demixing required. Why? It is a non-mixer. Whereas this is a mixer, therefore still segregation. But this will not continue. No, maybe sometime later you should get a non-mixer. Somewhere you have to get. Hence every path starting from this root node, sometimes you may get a stop here. You are stopping because you have got a non-mixer. Not stopping because still you have a mixer, but further if you go down somewhere you will get a mixer. Hence every path will end with a mixer only. Sorry, every path will end with a non-mixer. Non-mixer means you are stopping there. Means every path is going to end with a leaf node. Leaf node. And this is one pattern. Now green color, S1 shape, paste T2, maybe this is another C6. See, green color, shape S1, paste T2, they are all the objects belonging to C6. In C6 pattern is mixed up. C1 pattern is mixed up. Hence, I could be able to separate them. And this demixing is formulating a structure. It is looking like a tree. The tree is deciding the class. Therefore, I will call it as decision tree. And now, I have the problem that some x is given to me. Suppose that this X object has green color. Therefore, when I take this object here, what's its color? Green color. Therefore, I should not travel the other routes. I should come down only this route. Hence, I have already built the decision tree. I have built the model. What is this model? One pattern, second pattern, third pattern, fourth pattern, all these patterns are embodied. Therefore, this model is embodiment of patterns. Therefore, what I have constructed is a model. The model looks like a tree. Therefore, it is apparently a structure. The structure I can call, right name I can give instead of model. I would like to call it as a tree structure deciding the class, therefore decision tree. What I have constructed is a decision tree. I am using now, using for X. How to use it? To take the value. Which value? Here it is asking, what is the color of the object? Oh, green, go this way. Then what is the shape? Suppose shape is S3 and go down. Don't go S1 or S6, come down. Then suppose, and here you are stopped. Oh, stopped. What is here? C3. Answer it. What is the answer? C3. So decision tree is telling you C3 for this X. Use it. This is the way that you can use this model to answer this. I'm done. I have told what I want to tell, I have told. Now, questions are welcome. Hence, I have considered this problem as a mixer. I started thinking it as demixing will solve. When I am demixing, slowly the patterns are formulated, a structure is formulated, a model is built, and the model is used, and then done. Any doubt in this? There are good doubts should come, relevant doubts, definitely. Hence, let me expect what doubts that come to you. Otherwise, I will only raise the doubts and I will continue the discussion. But at present, I am done. In fact, I have done. I have explained the whole process. Yeah. Any doubt further? And first of all, is it clear to you?
Yes, sir, it is clear. Sir, I have one
Yes, sir, it is
question.
clear, sir. I have one question.
Yeah, please.
Like, how do we decide which feature
How do
should
we
we
decide
take
which
first? Like, we have taken color here.
take first?
Yeah.
Like we have taken
Yeah.
So,
color
if I
here.
have many
Yeah. Why not
features,
color?
and
Why color? Why
I
not
have
taste?
many features.
yes, sir, how to
Yes.
decide
Good.
which
Good.
feature
Yeah. Good question.
should be
How to
selected
decide
first?
which feature should be selected first?
Right. Good question. Yeah. Fine. Now, anyone else? I will answer it. I will answer.
Yes, sir.
Yes.
I will answer it. Yeah. Any other participant? Any other participant? Yeah. Hence, your doubt is, sir, you have taken color and then separated red, green, this. Thereby, you got this particular decision tree as a model, which is, of course, embodiment of patterns. Yes, all similar objects, tomatoes are separated, this pattern. C3 separated, C6 separated. They are all here. So for any given object, yes, I know how to use it. But fundamentally, your doubt is correct. Why you have started with color? If you have not chosen color, if you have chosen shape as the root, then you would have got a different decision tree starting at shape, maybe just one further divide with color, then taste, something like this. This decision tree would have been different. Why you have chosen color? Why not shape? Why not taste? Is that different decision tree? Any decision tree, is it okay? Yeah, any decision tree is okay as long as you are specifying the class of X. Definitely, this is a decision tree, this is also a decision tree, something else is also a decision. Because we are very clear that you start with any feature, either color or shape or taste. Ultimately, as you go on demixing, see now you demix it, then again you are demixing. Why you are again demixing? You didn't have a mixer. Here you are not demixing. Why you are not demixing? You have got a non-mixer. Hence, demixing along any branch will not further go if you get non-mixer. If you get a mixer, you have to go further down, demixing it. This is what happening. Therefore, every path ultimately it ends with a non-mixer kind, that is deep mode. Therefore, you choose anything, you will get a decision tree. But unfortunately, whether all decision trees are same or something better, that discussion we have to have. Hello. Only? John. ఇప్పుడు Hello. Yeah. Since now, since if I give freedom to you, some of you will start with the shape, some of you will start with the color, some other will start with the taste, and everyone will come up with a decision. Whether all the decision trees are same or something is better. Since a tree, which you know very well, it consists of the nodes and the edges. Nodes are there, edges are there. And of course, these nodes and edges are also there in the graph. But here the tree, of course, it has unique path to every leaf node from the root. Hence, when do we say one particular tree is optimal compared to the other? If I say that this tree is best if it contains less number of nodes and edges compared to any other. It means very quickly with less number of nodes and edges, I can reach the leaf nodes. Leaf nodes means the moment I reach the leaf node, I have decision is there, some C3, this is C7, this is C6. Hence, I am able to have the leaf nodes with the least number of nodes and edges in this tree. Therefore, people started thinking it is not just start with any feature and then have some decision tree. You start with, you will get decision tree definitely, but you may not get the optimum. Hence, how to make this the whole process which guarantees optimal decision tree. That is our next topic. Hence, first time I have got some decision tree which may be optimal, which may not be optimal. But anyway, I have an approach. This approach definitely gives you decision tree. My next attempt is how to make it optimal. How to make it optimal. It means the very first question is, at the very beginning, should I start demixing with color? Should I start with the shape? Should I start with something else? Which feature should be chosen for the root node? Hence, this is the root node. Shall I say color? Shall I take shape? Shall I take taste? Or anything? Because there are, how many features are there? N features are there. Hence, out of N features, which should be chosen first for the root node? This is the fundamental question. If you can answer it cleverly, then it may start towards the constructing optimal decision tree. Hence, how to answer this question? This is the question that she is putting. Very right question. But how to answer it? Means when you want to separate using color, I say, no, don't separate on color, separate on shape. Then you will ask why you want to cover the shape, why not color? I should prove that shape is the better choice, but how do you say it is better choice? Hence, out of N features, which should be selected here? Hence, it can be F1, it can be F2, it can be Fn. F1 is shape, taste, color, and so on. Which should be chosen first?
Sir, whether principal component analysis will help in this part?
Whether principal component analysis will help in this part, sir?
Principal component analysis. principal components. Hence, I have to find out the components which are principal. Hence, why should I select the principal components? That I have to discuss it. But some of you know that the PCA is for what purpose? For what purpose? Huh? Dimensionality reduction. Is it not? PCA is dimensionality reduction techniques. What is dimensionality? I will come to that. That's very good problem. What is dimensionality? Can anyone tell? Okay, I will tell.
So number of
And
features.
the dimensionality you want.
Number of features.
Yeah. Yeah, it is our hand. Yeah. Number of features. Okay, let us assume that it is number of features. Okay, start with your answer. This number of features you want to reduce. Suppose if I assume that your answer is correct, since dimensionality means number of features, reduction means number of features I want to reduce. Is that my question now? No. My question is very simple. I gave you n features. I am not asking you to reduce n to m. No, I am not asking. My question is very simple. Out of F1, F2, Fn, choose one of these. One is shape, another is taste, another is color. You choose one of these here for the root node. Which is better? Shall I write shape? Shall I write taste? Shall I write color? That is my question. My question is not that I gave you 50 features, reduce 50 features to 30 features or 20 features. That is not my question. Therefore, let us not try with this. Hence, my question is simple. Out of these n features, one should be selected. Clever. But what do you mean by that clever way of choosing it? How do you say that this is better choice than the other? That is my question. And whether dimensionality means number of features or not, that I will come at a later stage. First, I have started with her answer. Dimensionality means number of features. Okay, with that itself, we understood that dimensional reduction won't work here. Yeah, someone again, Jagadish joined. What is that variable importance? What do you mean by that, Jagadish Kumar? Yeah. Okay, let us attack the problem. The problem is simple. I have to choose F1 or F2 or F3, but something should be the best one, I should say. But which is the best? Why it is the best? How to choose the best one? Then I have to go fundamental. What I gave you? I gave you a mixer. I gave you a mixer. What is the problem with the mixer? Very first fundamental question, silly question. Again, I am going back to that silly question. My answer will be slightly different. What is the problem with the mixer? Nidhi Chauhan, what is the problem with the mixer? You give some answer, whatever you like.
So in the mixture,
Whatever answer that comes to your mind, you tell me.
so the items are having different features on the basis of which we can still separate them.
No. Control your minds. It is mixture of objects belonging to various classes. Yeah, this object has some shape, some feature value. Naturally, shape of this object may be different from the shape of the other object. Fine. Each object has its own feature value. Fine. That is not, we are not mistaken. Don't assume that some value is missing. No. I have not said that something is missing. Everything is there. Nothing is mixed. Nothing is missed. All are there. Hence, don't deviate. I gave you the mixer. What is the problem with the mixer? Hence, I will tell you one natural answer. And slowly know why I am putting this kind of questions. Without questions also I can teach. That interest won't be there. And tomorrow when you attack some problem, research problem, very natural question should emerge in you and very natural answer should come. Whether it is natural or unnatural, we can again debate. Now my point is, suppose today Nidhi Chauhan, morning, she prepared tea, chai. With what she has prepared? Milk. Have you really got the milk? No, sir. My milk boy, he adds water. Hence, it is the mixture of water and milk. Hence, one class is mixed, C1, another is C2, you have mixed up. Hence, what is the problem with the mixture? Come on, tell me.
So can we say variations? There could be.
No. Let's not bring big things. Yeah, Chauhan, what is problem with now your milk? Is it pure milk?
No, sir, it's a mixture now.
Is it a pure water? No. Suppose if I ask, please bring water. If you add some 5 drops of milk in it, then what is this? I asked only water. Why you are bringing impure water? His problem with the mixer is impurity. Milk became impure, water became impure. His problem with the mixer is impurity. Do you agree now?
Yes, sir.
Yeah. Hence, therefore, problem with the mixer is impure. Hence, therefore, when I demix it, impurity should go. If I demix it, if I can separate milk and water, then pure milk should come and pure water should come out. Suppose we have a device. We will pour this mixer, impure milk and water mixer. Milk will come separate, water can separate. Then we have got 2 pure quantities. Hence, the demixing operation will make, will reduce impurity. Is it not? Demixing is supposed to bring what? reduction in impurity. Therefore, when you are demixing two, hence each time you demix it, your impurity levels will go down. Impurity levels will go down. Hence, when you will stop demixing, that's what we have done. When we have taken all red color, here, pure one class, all tomatoes have come up. There are no more segregation. Whereas in the other, you have got, again, you have to separate it on taste, and again you have separated on this. Here you have got no more demixing. Here you have to demix it on shape. You are doing it. It means in some branch you are demixing, some branches you are not demixing. You are not demixing because you have got a pure class. It is not a mixer. Non-mixer. Non-mixer means pure. Or the amount of impurity in a non-mixer is amount of impurity in non-mixer is 0. Therefore, whether to demix it or mix it, demix it or should I stop demixing, it all depends upon amount of impurity. Hence my question is very simple. What is problem with the mixer? Problem with the mix is impurity. Hence you are attributing because of the mixing only impurity arises. Therefore, if you demix it, impurity will go. How to know that impurity has gone? Measure it. Hence, therefore, can you measure impurity in a mixer? Hence, how to measure impurity in a mixer? The next question. Hence, come on, think of how to measure impurity in a mixture. If you can measure, I gave you a mixture, measure it, how much impurity is there? Oh, this much impurity is there. Therefore, what I have to do? Demix it. Okay, I will demix it, and so on. Till along any branch, this impurity amount should become 0. Then only I stop there. Therefore, first of all, I badly need how to measure impurity in a mixture. How to measure impurity in a mixture? That's the next question. If I can measure it, impurity, if it is non-zero, I should demix it. Hence, if impurity in any given data set, if it is greater than 0, demix it. Once you demix it, this D will become D1, D2, D3, and measure again impurity in D1, impurity in D2, impurity in D3. Impurity in D1, suppose this is 0, it means don't demix it. Impurity in D2, non-zero, means greater than 0. This is 0, stop. Greater than 0, further demix it. D2 will become D21, D22, so on. Like this whole decision tree process, it all depends upon your amount of impurity. Therefore, try to measure impurity in a mixture. Then people started, should I design a formula to measure impurity in a mixture, or is it there already available in the literature? In Finland group in 1986, they started this way of thinking. 1986, you see, and they found that the answer already there another 30, 40 years back. Since around 1945, 50s, someone has a person, Shannon, born in 1916, when he was in MIT, he designed a concept called entropy. When he was young, around 30 years, means around 1945 sometime. Von Neumann was also there. He designed a formula for entropy. This entropy measures impurity. Measures impurity. Finland group in 1986, they have used this formula entropy there, and now we are studying it as a very new course as machine learning. Now you can think of the machine learning classification, they are old courses or new courses. Okay, now what is this entropy? And Shannon, when he was discussing the communication, since he has some information, that information he would like to code it in terms of data, and that he would like to send it through a medium, and data will flow, data communication, and the other side the data will be received, and it is again decoded and information is reached at the other side. This is what we are learning in data communication, computer network, physical layer. This is all you know it. In physical layer only, that no media is perfect. This data, when I am sending 101, it may not receive as 101, it may be received as 111. Means one particular thing is Darwin. Means how do you know the error, how to detect the error, correct the error, all these things we have studied. Hence, here quality of this transmission depends upon the signal to noise ratio. Hence, that entropy is in the form of signal to noise ratio. It is in this form. And here we write signal to noise ratio, but Finland group for this classification problem, they have not taken signal to noise ratio. Here there is nothing like signal to noise. Here, of course, I can continue this, but it will take longer time. Hence, I am cutting now. Here, we would like to use the probabilities. Minus sigma pi log pi, where I is equal to 1 to m. This m is the number of classes. M is number of classes. How many classes you know? C1, C2, Cm. C1, C2, Cm are m number of classes. C1, C2, Cm. That m and this m is equal to 1 to m. This is the formula for entropy. This is the formula for entropy. Okay. Hence, let us assume, I can answer this question, but I am assuming here, okay, entropy formula is taken. And this entropy indicates amount of impurity in the given data. Amount of impurity in the given data. It's okay, let me write here minus sigma pi log pi. I is equal to 1 to m. This is entropy. Hence, impurity in the given data set is given by this formula. Hence, I have measured impurity in the given data set. Now, this impurity you want to reduce it. How to reduce? Demix it. How to reduce impurity? Impurity arised because of the mixer. If I demix it, impurity happened. Why? Because of the mixer only. Demix it, impurity may go down. But now the question is, if I use color, here at the beginning to demix it, will it reduce impurity much, or shape will reduce? Shape is better or taste is better? Which feature is better? That is the fundamental question. Which feature is better? Whichever reduces impurity considerably compared to the other. Which one reduces much? That you prefer. Therefore, my next question is, if I choose color, how much impurity will be reduced? Impurity reduction.
What happened? Manas, are you there?
Sir,
Is it coming? Are it visible? Research person visible?
What, sir?
Research person visible?
Sir, I think he is disconnected.
He is disconnected. Let me choose. Are you disconnected?
yeah, I was talking. Impurity, how much impurity reduces if I choose color? How much impurity will be reduced if I choose shape? How much impurity will be reduced if I choose taste here? Hence that I want to compute. How much impurity will reduce if I choose color, shape, taste. Hence for each of these, if I can calculate amount of impurity that color will reduce or shape will reduce or taste will reduce, whichever reduces higher amount of impurity, that should be preferred first. Is it right choice?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Therefore, how to know how much impurity reduced because of color? I will try to formulate equation. If I use color, how much impurity will reduce? If I demix on color, how much impurity will reduce? No, not color, shape. Okay. If I use shape, how much impurity will be reduced? This I want. Then, you know total impurity? Impurity in D. Impurity in D. Impurity in D. D means this original data set. This original data set, if I use color, it will be divided into 4. Red colored, D1, blue, D2, green, D3, yellow, D4. D is divided into D1, D2, D4. Here there is some impurity is there in D. In D1 also impurity will be there. In D2 also impurity will be there. D3 also impurity is there. D4 also impurity is there. Hence here amount of impurity in D1, amount of impurity in D2, if you add this, this is the remaining impurities. Hence impurity in D, this is original impurity or total impurity, whatever you want to say. Total impurity. Leftover impurity. Leftover means impurity in D1, impurity in D2, you sum it. J is equal to 1 to 4. 1, 2, 3, 4. If you separate it, hence original minus leftover is the amount reduced. Do you agree? Original impurity. After segregation, you got 4 data sets. Each data set has its own impurity. Sum up it. Sum of the impurities of D1 plus D2, sum of impurity in D3, sum of impurity. You sum up it. Hence total minus leftover is the reduction. This is true for the shape also. Only difference is original impurity is same, but only thing is whether there will be 4 DJs or 3 DJs, we don't know. Suppose instead of color, if you use the shape, you may get only D1, D2, D3. In that case, the sigma will run only from 1 to 3. Because this side, these DJs are different, these DJs are different. These are all D1, D2, D3, D4, which are red, blue, green, yellow. Whereas here the shape, you have taken shape. Shape is S1, S2, S3. Hence always my formula is same. Total minus leftover is the gain. Total minus leftover. Hence, this people have used a different name. Instead of impurity, they have used the word info. Means leftover impurity, means leftover information. This impurity reduction means you are gaining your advantage, no? Some gain of the color. Since you calculate gain is a measure. Gain you calculate for each of these features. Info D. This info D is given by this entropy. Hence, this is the formula which we have to use to calculate gain value for each of these. And then whichever gives the maximum gain, whichever reduces the impurity much, that should be chosen here. Now here confusion is, suddenly you have jumped from impurity to info and you have used the word gain. So far conveniently you have used the word impurity, and now how impurity and information, these are all related. I will come to that point. First of all, what is this PA? What is this PA? PA is, hello? రాత్రి కడతామమ్మా, రాత్రి పే చేస్తాం. ఇదే కదా మన కార్ లైసెన్స్ ఇన్సూరెన్సే కదా. This PA, log PA. This PA is probability of any arbitrary object belonging to CA. Hence PA is probability with which an arbitrary object belong to class CA. This is the probability. Do you know how to calculate this probability? And what is this probability? And then we will come to understand what is information, impurity, are the same, different, all these things will come to you. But this is very much required. How to calculate the probability with which an arbitrary object belong to class C. How to calculate this probability from this data, because these PAs are required. How many such PAs are there? As many as the number of classes, because I is equal to 1 to m, C1, C2, Cm. PA means I is equal to 1, P1, I is equal to P2, means CI, PA. Some people write PCI also, PCI. Hence PCI or PI both are same. Probability with which an arbitrary object belonging to CA. How to calculate this? Can someone tell? Only probabilities, is not nothing machine learning, not great thing. Simple, I am asking. I want to choose some object arbitrarily, randomly choose an object. That randomly chosen object belong to class CA with some probability. How do you know? This is the probability with which an arbitrarily chosen object belongs to CA. Very trickily I will put the question. Suppose your father has brought all fruits and vegetables. You will pick up some object at random. Suddenly you will put your hand and pick it up. And one object will come. What are the chances that it is an apple? Your father has brought apples, oranges, some other vegetables, and also all these things are mixed up. Hence, what is the chance that a randomly chosen object is an apple? How to calculate that probability?
Sir, so it's total number of apples divided by total number of items in the bag.
Yeah. Hence, total number of apples. Suppose there are 5 apples and there are 500 objects in the bag. That's 5 by 500 is this?
Yes.
Okay.
Yes, sir.
I accept it. Yes, because again, if I go into the question, it will take another half an hour to come out. Okay. We accept it. Why? You know, and others, some of the others also know. Let us assume all others also know. Okay, yeah. If I go, some more details will come out. If I enter into it, it will take some more time. Already we are now reaching the lunch break time. Okay, now PA, somehow you have got the answer. Okay, fine. Yeah. Now, since therefore, how many PAs will be there? P1 will be there. P1 means PC1, P2, PC2, both are same. One is apple, another is tomato, another is potato, like this. Totally, there are m number of classes. PM. Okay, fine. Suppose your father has brought only apples. Only apples. Nothing else is there in the bag. Generally, he brings all in the mixer. But on one day, somehow he brought only apples in a bag. Only apples, certain number of apples are there, but only apples. Therefore, is it a mixer or non-mixer, first of all?
So it's a non-mixture.
Fine. And now, my next question is, what is the probability that it is an apple? My C1 is apple. What is probability?
Sir, it will be 1.
1.
If there are only apples in the bag.
Only apples, that's what I said. Okay.
Then it is 1.
Only apples are there. Therefore, suppose there are 5,000 apples. 5,000 objects are there, 5,000 apples, therefore 1. That's why your answer is 1. Because others also should know it. Hence, your P1 is 1. In the same bag, what is the chances that an object is orange? In the same bag, where only
0.
apples are.
0, sir.
0. Since all other classes are 0, first C1 is 1. Now you put in this. Now put in this. Expand it. Minus. We expand this sigma. Expand P1 log P1. Is it not? If I expand, what is that? P1 log P1. P2 log P2. and so on, PM log PM. My P1 is 1, therefore 1 log 1. Other things, other PAs are all zeros. Means 0 into log 0, 0 into log 0. Therefore, this answer is log 1 is 0, therefore this 0. Of course, log 0 is minus infinity, but generally we are multiplying 0. Hence, in computer science, we take zeros. Therefore, the whole answer is this value is giving you what? What is minus sigma PA log PA?
0.
0. I said this is giving you what? Amount of impurity. Now, how much impurity is there?
0.
0. Do you agree? Yes.
Yes,
Because
sir.
your bag is full of apples.
Apples.
Full apples. No, there's nothing like impurity. Same class. All belong to same class. Hence, impurity is 0. Impurity is 0. This impurity word, impurity, confusion, some different words you can use. Ambiguity, different contexts. Since we have taken milk and water, I thought impurity is the right word. Suppose if I mix up too many concepts, then lot of confusion, sir. You segregate, sir. You teach one by one. Why you are confusing? Hence, mixer sometimes confuses. And if I mix up something, no, there will be ambiguity. Oh, it's ambiguous. Why? It is because of the mixer. Oh, if you demix it, that ambiguity will go. Hence, in some application, you feel right word is ambiguity. In some other application, confusion. In some other application, impurity. Whatever it is, whatever the word, these are all ambiguity, confusion, or impurity. These are all arising because of the mixer only. Because of the mixer only. Hence, when I am measuring entropy, I am measuring impurity. In another application, I may say that I am measuring confusion. In another application, I may say I am measuring ambiguity. And here, there is no ambiguity. All are tomatoes. All are, what is that? Apples. Suppose if father mix up some 4 or 5, by looking at the bag, can you say this is bag of apples? No. Apples are there, oranges are there, potatoes are there, tomatoes are there. It's a mixture, sir. I can't say. There's ambiguity. You won't say there is impurity. In milk and water, you'll say impurity. In a mixture of vegetables, you will say there's a lot of ambiguity. I can't say it is apples. It's not apple bag. On the other hand, suppose only tomatoes, tomato bag. Mixture, ambiguity. Hence, ambiguity, confusion, impurity, whatever the word may be, it's all indicated. But suppose if I use the word information, do you agree? Information is 0. Hence, people generally use information word. Info D. Info D is given by entropy. Information in data set. Information in data set. Info D is given by entropy. This is what the bookish knowledge. Yeah, information in the data set is given by entropy, that is minus sigma PA log PA 0. Suddenly, when I was taking my very first class, my student asked, sir, information in the data set you said that is given by entropy, but when it becomes 0, when all belong to same class, when all are apples, in such a data set, your information is 0. Do you say that information is 0 in a data set? Information 0 means there is no ambiguity. Suppose my talk is unambiguous. Is information full or not? Information is full. When ambiguity is zero, information is full. Here, though they have used the word information, right word is, I don't like information word. I like which word? Ambiguity word or impurity word. That's why I started with impurity word or ambiguity word. I don't want to use info word because here it will naturally agrees. Oh, if this quantity becomes zero means ambiguity is zero, impurity is zero. But why majority of the people in this world, they don't use ambiguity? Why they use the word info? Because info and ambiguity both are reciprocals. If ambiguity is zero, information is full. Information is zero means ambiguity is full, maximum. If maximum ambiguous talk, then information is nothing. Nothing will be there in my talk. If all are ambiguous, oh, this fellow talks all nonsense, all ambiguous. Therefore, this is something like dark and light. If there is no dark, light will be there. If light is there, dark should not be there. Hence, in general, in our science, people don't like negative words. In physics, there is chapter on light. There is no chapter on dark. There is a chapter on heat. There is no chapter on cold. Hence, light, dark, cold, these are all negative words. Positive words are heat, light, information. Hence, people don't want to use negative word ambiguity, impurity. They want to use right positive word info. But this is also indicates info. But underneath, it's not really, if you are confusing what is this information, how it becomes zero means information is full, in fact. Hence, how much information hidden in the data set, the mixture information is there means no one will convince. Now you rewind my lecture. If I start, there's a mixture, the mixture contains information. Oh, what is this mixture? How it contains information? If mixture contains impurity, impurity is measured, impurity became zero, impurity has another word, ambiguity. If ambiguity is zero, information is full. Oh, good. How much impurity is reduced or how much gain of information? Because if I don't know about one participant, no, I want to know information about you. Then I start questioning. Oh, Nidhi Chauhan, what is your specialization? Okay, you will tell something. Then I will know something about you. Yeah, how many years of experience you have? 20 years. Then another question. Means each feature, specialization, experience, or area of research, your college institution, and how many students are there, what are their work. Yes, each is a Yeah. Yes, continue. Generally here we won't get any trouble in the NIT campus, but today somehow some power problem is there. It's running on Wi-Fi. Now and then it's getting disconnected. Anyway, since ఏమైపోతావు is therefore this is how we have to select which feature to be at the beginning. Fine. Okay. Anyway, let us take break now. After 1 hour, 45 minutes, I will join. After 45 minutes, I will join after lunch. We continue with another topic. Okay.
45 minutes. Huh? Now it is 1:30.
I will come back. Okay,
2:15 minutes.
phone చేస్తూ ఉండకండి రావాలి మేము కమిషన్ ఐ విల్ జాయిన్ ఎనీవే
Okay, sir. Okay.
I'll go home and take lunch and come back. Meantime, internet problem will also be solved.
Okay, sir. Connection online. Yeah.
Particularly in 2 minutes I can have because anyway net is there. Chauhan, any doubt whether it is clear?
Sir, I have a small query in this.
Yeah, please.
Sir, you are telling that this impurity is induced by the features which are adjoining our feature of interest. So, in this, if you we understand in this way, do you think that we are going to a platform of this biased sort of insights? So, how we can justify this? There is an optimal impurity in this case because you are telling that impurity is because of induced because of the feature adjoining our feature of interest. So, will you please
Not
explain
features.
that, sir?
No. Features I have fixed it and features are there. Is mixture of objects, not because of the features.
In that case, we can delete that features, no, sir, which you are creating disturbance in prediction analysis.
Hello?
Sir, is it true that we can delete that features which are creating some problem?
Sorry, again you are again you are mistaking. Impurity is not because of the features. Impurity is because of the mixture of the objects.
Okay.
If it is for the feature, no, I can remove on a feature. It is not because of the features. Mixture of objects. See, I have right from beginning I am telling mixture of objects. This mixture is mixture of objects. It is not mixture of features. It is mixture of the objects. Objects belonging to various classes. Say I have mixed up tomato, potato. This means did I mix shape, color, or did I mix tomato, potato? I have mixed up objects belong to various classes. If objects are all same class, that's what I have taken just now example. If all are apples, then there is no mixture. All are apples means no mixture. In that case, entropy becoming 0. Hence here mixture is not because of the features. Mixture is mixture of objects. Impurity is arising because of the mixture of objects. Therefore, by removing one feature, that problem will not be solved. Okay?
Thank you, sir.
Yeah. And that's why, see, you have mistakenly taken that it is because arising because of the features. No. If features are inducing impurity, then I would have opted for you. That is not the case here. Mixture of the objects. Yeah. Any other doubt? Yeah. Yeah. Neetu Chauhan. Want to tell something?
Yes, sir. It's clear, sir. Now.
Right. Afternoon we'll see.
Okay, sir.
Lunch break. Sir told after 55 minutes, sir will come. So most probably 2:15 next session will start. Right? Is it clear?
Yes, sir.
The next session will start most probably 2:15.
Okay, okay, sir.
Good afternoon, sir. So actually, I just want to confirm when the session will resume.
Yeah. Now we start the session. Yeah. Any doubts at the morning classification using decision tree, where the tree structure is helping us to decide the class. The nodes, internal nodes contain the features. Leaf nodes contains the class labels. But which feature should be taken at the beginning and then in which order, based upon the amount of impurity reduced or information gained, that I have explained. If you have any doubts, let us discuss. Otherwise, we'll go to the next topic. Yeah. But we have taken the training data set having certain features. If it is training data set, means you will be taking the data of labeled objects. Hence, there may be an additional column of class label. If you are not taking the labeled objects data, then only the features will be there. Then it is data about unlabeled objects. Hence, both the labeled and unlabeled objects data can be considered, and some knowledge can be extracted for various tasks. We have taken labeled and we considered one task called classification that we have discussed. And in between, many times people were confusing that I am trying to control the features. No. I have taken the n features, I did not touch it. I did not touch it means I'm assuming that all those features are required. But if we doubt about them, that shape, color, taste, and so on, n features are there, whether all n are they necessary? Are they necessary? Or any one of them is unnecessary? This question can be put. And sometimes all these n features, say I give only shape, color, taste, only 3 features. With these 3 features, can you have knowledge about all vegetables and fruits? No. In that case, the taken list of attributes may not be sufficient. Hence, another question is, are they sufficient? Hence, about features, we question this, whether these features are the necessary and sufficient. Hence, two issues. Hence, this also can be taken as a problem. We can have some discussion around this problem. Okay? Yeah. Okay, something unnecessary, if you can prove that some feature is unnecessary, you can straight away remove them. In case if we know that they are not sufficient, then we have to think of which features are not included, and that all depends upon the application of the domain knowledge. Hence, therefore, I will be taking the related problem called morning we were discussing. Someone was bringing quite a 2-3 times this topic called dimensionality reduction. Since what you understood from this problem, what you want to do in the name of dimensionality reduction. Morning someone gave some meaning, and with that I have somehow finished off that particular context. But now let us have a full-length discussion on dimensionality reduction. Now, can someone initiate it? What they understand? What do you mean by dimensionality reduction? Yeah.
So reducing the features of in the data. So reducing the number of features that we have.
Okay. Reducing the number of features. Okay. Then they would have called it as feature reduction. Okay. Next. Any other interpretation? Any other participant? ఎందుకంటే నెట్ అక్కడ అక్కడ స్విచ్ అక్కడ స్విచ్ డౌన్ ఏంటన్నా చేశాను. Yeah. Okay, let us come back to the Chauhan, Nitu Chauhan. Yeah. Dr. Nitu, now why do you feel that certain features can be removed? Why that need arises?
So chances are there that some features may be interrelated to, they may be conveying the same information.
Okay. That's why if both the features are conveying same information, one of them is sufficient to be there, the other can be removed.
Yes, sir.
So, how do you know that those two are conveying same information? Okay, I agree to some extent. Okay, suppose if we think that there are two features which are conveying same information, then one of them you want to remove, that is fine. But how to identify those two that they are conveying same information in a data set?
So we need to have some measure to find out correlation or something like. So if I can find out the correlation between the features.
Okay. Since if they are correlated, positively or negatively, then we can remove them. Okay. Correlation is one thing. Fine. Hence, correlation is indicating that one is related to the other, one is depending on the other. Therefore, we can keep independent one and remove the dependent one. Is it right?
Yes, sir.
Yeah. Hence, on the other hand, you want to find out the dependent ones and remove them. Okay? All dependent features
Yes,
should be
sir.
removed. And finally, you should have only independent features. That is your objective?
Yes, sir.
Right. Hence, we want all our F1, F2, Fn, whatever the features are there, they should be independent each other, mutually independent. None of the features should be depending on any other or some. Hence, only independent features are to be taken. That is the goal of the dimensionality reduction according to Neetu Chauhan. Now, any other person disagree with this or agrees? Yeah. Hence, now finally, the problem of dimensional reduction is searching for independent features. That is one thing. And here, she is almost concluding that the dimension means feature, number of features. Hence, dimension means features and dimensionality, it means number of features. That is the conclusion. Hence, if you can successfully remove dependent features, then there's possibility of that number of features is also reduced. Okay. Yeah. Anything else people have seen in dimensional reduction? Okay, let me take you to the fundamental point. I will give you the data of two variables, x and y, and I note down the values. Since that's all, this is the data given to me. Since there are some values here, if only two variables, that is quite easy. If suppose y is function of x, we might have discussed this in the other topics also. And if my points are like this, say for example, x and y are height and weight, and Dr. Kumar has chosen the participants for this FDP. Now one application he has received. He has some height and weight, some H1W1, first participant, he has accepted. Now another application, second application has come. That also he has accepted. The third application has some height and weight, but he rejected this. And he said that seats are already filled, no more vacancies, rejected. But yet another has come 4, is accepted. 5 accepted, 6 accepted, 7 rejected, 8 accepted, 3 rejected, 7 also rejected. Things like this, 120 participants are selected. Their heights and weights are all on this line. They are all on this line. Yes, basically I have two features. One feature is height, other is weight. Two features. Two features. When I plot the data, the participants' heights and weights are all on one line. Now, is it two-dimensional or one-dimensional? That is my question. Is it two-dimensional or one-dimensional? I have taken two features, height and weight, but I have selected certain participants whose heights and weights are all lying on one line. Now, such a data, is it one-dimensional or
Two-dimensional?
2 dimensions, sir.
Any reason? Since here the number of features in the given data has to be 2, and hence you are saying 2 features. And Nitu Chauhan, you said that if one is dependent on the other, yes, it is very clear that this particular, no, x and y, if I write, suppose x and y, if I write, this line is y is equal to mx plus c. I am fitting a line. When I am fitting a line means this weight is depending on the height, y is depending on x. X is independent variable, y is dependent variable. According to you, y should remove one. Y should be removed, and it should be only one feature. If one is depending on the other, you said that remove dependent and keep only independent, then it should be one dimensional. I should remove one of the feature. Do you agree? Now I'm only created one example for the discussion what you said. If you remove simply the dependent and keep independent here, then W should be removed, because I could able to get the W is equal to some mh plus constant, like y is equal to mx plus c. In y place I have W, x place I have h. See, our lectures and all, see, that's what many, nowadays what happened, many faculty are currently teaching and many are listening, at least some of the other FDPs. In due course of time, certain concepts are not becoming clear. That's why I have chosen entirely different kind of this thing. I want to clear these ambiguities. And at the same time, I am saying that what you said is correct. But now I have created this example and I am trying to prove that you are wrong. But ultimately, I am going to prove that you are correct. But meantime, how do you know that you are correct? Yes, now I have created a story that your dependent variable W should be removed. Remove it, then it will become one dimensional. Is that what you are going to do in the dimensional reduction? Have you got the point, Neetu?
Yes, sir. Yes, sir.
No? Yeah. Hence immediately you may be trying to no, sir, not that. Hence here, even there was another person, I could not see his name. He was also telling this is two-dimensional data. Hence now, why you are telling two-dimensional? The reason will be, sir, there are two features, therefore two-dimensional. Therefore, our total concept saying that number of features is equal to dimensionality, that itself is something question mark.
Sir, XY is there, no, sir. That's the reason why I mentioned it is two-dimensional. Since we are seeing X and Y.
Two-dimensional features are there. Therefore, two-dimensional. That is your conclusion. Is it not?
No, sir.
That's the
It's
only
just an
basis.
assumption from my side.
Hello?
Yes, sir. Yes, sir.
Yeah. Hence, the basis for your conclusion is there are two features, height and weight. X and Y axis, therefore two-dimensional. But according to her, out of these two, one is dependent, another is independent. The number of independent only should be there, dependent should be removed. Therefore, it cannot be two-dimensional, it should be one-dimensional only. Means how to put these two together. That's why I started first question. Anyone would like to disagree with her? She said that there should be only independent features. All dependent features should be removed. Yes, here I have proved that there is one dependent feature, another is independent feature. The number of independent feature is only one, therefore it should be one dimensional. But both of you again saying that no, sir, it is two dimensional. In sense, therefore, there should be some clarity should come. Means first thing from this, the moral story is, it is not the number of features indicating dimensionality. Means dimensionality equal to number of features, that is wrong, first of all. Wrong means after performing some dimensional reduction techniques, it may be equal. At present, it is not. Okay. Now, if you see this data, each point has some x coordinate, that is height, and that's why each is having two coordinates. The two coordinates, one is along the standard axis, x-axis, another is y-axis. Hence, if you look at this data points from this traditional standard coordinate axis, Cartesian coordinate axis, each point has two dimensions. Okay. Now, forget about this two dimension. Forget about the standard axis. You try to create your own axis. You try to create your own axis. The axis along this line. Hence, I am creating a new axis along this line. Then all the points are on one line only. Therefore, it is linear. It is one dimensional only. Therefore, though this data set contains two features, when I have plotted them and created my own axis, only one axis is sufficient to represent it. Therefore, the dimensionality of this data is 1. Though the number of features are 2, number of features is 2, dimensionality is here only 1. Hence, I could able to reduce from the assumed, if you take number of features is equal to dimensionality, that dimensionality I have reduced. It is just 1. It is not 2. That's all. In the last 2 minutes, what I have said, don't go by the number of features, and don't look at from the standard coordinate axis. You try to draw your own axis and see how many new axes are required to represent the data. If only one axis is sufficient, one dimension. Two axes are required, two dimension. Okay. This is what I would like to convey. Now, I will take up yet another example. There may be 3 dimensions. Since naturally one point means there will be some x-axis, y coordinate, z coordinate. Therefore, any point has x, y, z. In certain x, some y, some z. This is the point. Since like this, there are points in this 3-dimensional plane. And unfortunately, all those points, they are all lying on one plane only. They are all lying on this particular plane. Only small plank. And no point is below or above. All the points are on just this plank. Though each point is like the previous one, it has its own x, y, z axis. Since all the points are on one plane, the data of these points, they formulate 2-dimensional, not 3-dimensional. And those 2 dimensions are along the lines that what we draw here. These are the 2 axes which I am going to create, and the points lie on those only. Hence, those 2 axes are sufficient to represent the data. You can just forget about the standard axis. Since this is another example, even sometimes what happens, though 3-dimensional data you may take 3 features, but all the points may be on just on one line. Then the 3-dimensional 3-feature data, finally I am able to reduce it to 1 dimension. Other 2, no, only 1 dimension. Hence, this is how, though apparently there may be a certain number of features, n may be there, but the dimensionality I can reduce to m, where n, this happens. This happens. Why it is happening? What is the real meaning of dimensionality? How to reduce it? These are all the discussions what we would like to have now. Okay. When I said that this H and W are depending on each other and they are all lying on one line, though basically these are the points on 2 standard axes, one is H, another is W, I would like to create my own standard axis. My own axis. This is the new axis formulated. Since all the points are lying on one axis, I claim that it is 1 dimensional. What is that 1 dimensional? I have asked Chauhan, Nitu Chauhan, since W is depending on H, will you remove W? She said, no, sir, don't remove W. Hence, you can't remove W or H. But her intuition is telling that one is depending on the other. When one is depending on the other, why you want to have both? You can, independent only should be kept, dependent should be removed. But how to remove that? That she don't know. But her intuition is correct. There is a variable, dependent variable, depending on independent. Only independent should be there. Dependent anyway need not be there. Because from independent only you will get dependent. when y is equal to function of x, only x matters. See, whenever x changes, y will calculate. You can calculate. Suppose x I give 2, you will put x is equal to what is y, you can calculate. When x is equal to 3, suppose y is equal to x square. Yeah, 2, 4, 9, like this you are telling. Do you want to have both? Hence only independent you want. Hence her intuition is correct. But how to do that? That is the only problem. That's why I said you are correct, but at the same time, when I ask you to remove, you are unable to remove. Hence, intuition is correct. It means it is one dimension only, but what is that one dimension? Means only one feature you want to have. What is that? That you have to find. Hence, it is something like you will have the, instead of having two values, H and W, for each participant, say participant ID for the application 1, application 2, application 3, 4, so on, 106. Each heights and weights are given. Heights and weights are given. Now, instead of having two values, pair of values, now since one is depending on the other, I can have some W by H. BMS value, body mass index, what it indicates? BMI. Body mass index is ratio of this height and weight. And some function if you take, and if you replace this instead of two values for each participant for T1, 2, 3, 4, I will write only BMI value. It means in the original data set there are two features. I observed that there is one is depending on the other. Therefore, I know that it is going to be one dimensional and I have created a new feature. I have created a new feature. And the number of features now it is only one. Therefore, the number of features originally taken and after reducing, after creating this, I have successfully dimensionality reduction has taken place. Okay. Hence, what happened? Given features are H and W. I don't want those. There are two features, but I have constructed a feature. Hence, in dimensional reduction, it is not only removal of the features. Sometimes what we do, we construct the features. Since I have taken two features, I observed that one is depending on the other. Therefore, I have created a new feature. Hence, feature construction has happened, and thereby I got only one dimension. That is what the activity that I am doing here. But is there something theoretically can we attack this? Okay, practically what you are telling, sir, is fine. You have drawn one figure and all are lying on one line, and something you have brought a body mass index, you have created and you have shown and you have constructed feature. Hence, I have conveyed. Don't simply go by number of features, though there are two features, you can reduce it to one. There is dependent, there is independent, feature construction, all these activities I have shown. Hence, what is the now the true meaning? how to draw this particular new axis. There are two things, let us look at it. How to draw this new axis. Hence, when I said, when the points are like this, standard axis may be here and there. I don't bother about it. See, in your village or in your town, do you think that all the streets are all along northeast and east-west kind of thing? No, you spread something like that. Hence, when you have these points, where you want to lay a road, suppose the houses are like this. Somehow people have come, they constructed houses along like this. If I want to put a road, I want to lay a road, pave a path. Do you say no, northeast only should be, or east-west only should be there? Do you want to draw one road here? If you put a line, if you lay a road here, will it be convenient to the people? If you put road like this, and if houses are H1, H2, H3 like this, no one will agree with you. Though this road is not convenient. Therefore, the road should be along. The road should be along this way. Then all the points are all convenient. Immediately they will get onto the road. Whereas my previous choice of the road like this, that was only convenient to two people, where all others they have to come away. No, they are all away. This is the best way of identifying the road. Hence, if I draw like this, only these two people, these are all, no, they have to come in the fields. They have to come, no, they're all far away from the road. Therefore, for certain applications, since we don't go by the standard axis, we want to study which is the best way of putting the roads. Then why you are suggesting that this is the way that road should be there? Your eyes are there, they are aware of the answer. Since your eye is telling, put the road like this. If you ask why you are suggesting here, it won't talk with you because your eyes are not your eyes. Since we think that it is my eye, but my eye won't tell me. No? My eyes and my lungs and my heart, everything is in the control of someone else, in the hands of God. Hence, they won't tell us. If my brain is my brain, sometimes it won't cooperate in the examination. After we come out of the examination, the answer will come to our mind. Oh, after 5 minutes before if that comes to know, we would have written the examination well. After coming out of the exam hall, only your brain will supply the answer. Then do you think that your brain is your brain? Hence, like this, now your eyes are telling, put a line like this. Why? It knows the answer, but it won't tell. If you persistently ask, then why it is suggesting, hence, then you will come to know that your eye is catching the spread of the points. Hence, spread is along this line. That's why you are not suggesting this line or this line or this line, like this kind of lines you are not suggesting. The line of way, that is the road you are suggesting that it should be along the spread. Hence, you are catching first the spread of the points. Hence, there may be the points like this. Suppose the points are like this. Houses are like this. Then if funds are available for one road, whatever the length may be, we don't bother about x-axis, y-axis like this. These things we won't bother. Always we study and put that the first spread is this. Maximum spread is occurring along this line. Hence your eye is catching best spread is along this. Maximum spread is along this. Hence this is the first principal component. First principal component. First principal component. First your first principal component is a new axis you are drawing along the maximum spread points. This morning someone was talking principal component analysis. Hence you are analyzing the principal components. Hence the principal component, first principal component is along the maximum spread of the points. That is your first principal component. Second principal component is it should be perpendicular to this and along the next best spread. Means the perpendicular lines I can draw like this. Also I can draw like this also, perpendicular to the bird. But out of the several possible perpendicular lines, this is the best spread. Hence next best spread is here. Because there is a peak here. Hence, though the original axes are two, OX and OY, here also I have drawn two lines. One is a new axis, this axis, another is this axis. Hence, the number of newly created features, one is along this, another is along this. Hence, how many new axes I have created? 2. Originally 2. Is there any reduction happened? No. But still we prefer this new axis, not the old ones. This is another example where I am showing sometimes the really reduction may not take place. Old also 2 features are there. Old axis also 2 axes, x-axis, y-axis. I have created new different axes along the spread. Here also how many axes are required? 2. Why are this new 2? Why not you take old 2? No. Old 2 are not preferable. The new 2 are preferable. The new 2 are drawn as per the spread of the points. Therefore, if you draw roads like this, suppose one road here and one road here, compared to this road, these two roads, compared to these two roads, the roads which I have suggested with arrow mark, these are better roads. Therefore, we should not consider the given feature. Sometimes we have to replace the features, given features with the new features. Since always sometimes we may go for feature construction. In this feature construction, sometimes same old feature may be there, may not be there. New features may come, and the total number of features may be reduced, may not be reduced. Means anything may happen. Anything may happen. Okay. Hence, I hope now you understood only one word. that principal component is nothing but along the spread. What is first principal component? That is along the maximum spread of the points. Next principal, second principal component is it should be perpendicular to the first and it should be along the next best spread. Is third required? Yeah, if third required, go for third, but that should be perpendicular to each of these first two. And the third one should be perpendicular to the first principal component. Third one should also be perpendicular to the second principal component. Hence, all the principal components are mutually perpendicular. All the principal components should be mutually perpendicular. The first is along the best spread, second is the next best spread, third is the next best spread. Like this, you have to continue. How long you have to continue? How do I know that no more principal components are to be considered? That is the next doubt which should come. Instead of asking, do you have any doubts? I am only raising the doubts and putting it. Okay, these are the things. Second thing, since I am explaining in a graphical manner, that is just I am drawing the points on the board. Hence, your eye is able to understand very easily. Even much before I say the answer, your eyes knows the answer. And only I am convincing you. See, your eye is telling this, the reason is this. That's what I am telling. Hence, answers are known to you. Only thing is, I am reasoning why the answer in your mind, in your intuition, given by your eyes, why they are the right choices, right answers. I am giving only the justification. But unfortunately, when I take some 10 feature data, can you draw 10 feature data on the board? See, for the 3 dimension itself, I have struggled a lot here to represent points in a 3-dimensional plane. Hence, if the number of features are more than 3, you cannot represent them in this on the board, and it is maybe true for some choice also. Hence, as you go to the high dimensional, plotting the points and investigating the spread, because unless you catch the spread, no, you can't define the new axis, new principal component. Therefore, how do we understand the spreads? Is it only by plotting the points? That is not possible beyond the certain dimensions. Therefore, instead of the graphical method of finding the spread, can we have any other method to catch the spread of the points? That's what people have started thinking. Hence, what I am suggesting now, the PCA dimensional reduction is, it is more than 100-year-old topic. More than 100 years, almost 100 years, 100 plus nearly. Hence, these topics you can imagine, though we are studying now, very old topics, nearly century-old techniques. Okay. And at the same time, you can't you apply sometimes. That's what morning I have commented. You should be very careful when you can apply and when should not apply these things. That's why we are going into the theoretical details of these techniques. Fine. Yeah. Now what I will do, I will first try to give the true meaning of the dimension, first of all. Okay. With this, you have to clear all whatever you had in your mind, the previous thing. Slowly you have to clear it. Now we are getting the true meaning of these words. Now, pretty well you know that if I take a 2-dimensional plane, is a 2-dimensional plane. Why we are calling this as two-dimensional plane? Again, the question is silly. What is this or why it is two-dimensional? There are two dimensions, y-axis, y. X-axis, y-axis, there are two axes you have drawn, therefore it is called two-dimensional plane. Two-dimensional axis, the points are there. And knowing that you are putting very silly questions, why it is two-dimensional? Yeah, because conveniently our high school teachers, these teachers know, they have given some easy way of, they have chosen some easy way of introducing the subjects. It is not their fault. At that age, they can't teach anything more. If I become a high school teacher, I will be a poor teacher, because if I try to put all these things in the minds of the children, they will be confused. Hence, at the stage, that is the only way of telling, and that's why they have chosen the best way of doing it. But as you grow, you should understand the details. Why it is called two-dimensional? Answer is not because there are two coordinate axes, two dimensions. No. Whether anyone knows why it is called two-dimensional? That's why some of these questions now appears to be silly. Why two-dimensional? Yeah. See. Now, how many points are there in this two-dimensional plane? Infinitely many. Though points are infinitely many, all these points are generated by only 2 points. All these points, you take any point, it is generated because of 2 points. What are they? One is 1, 0, yet another is 0, 1. One, 0, yet another is 0, 1. These are the 2 points. You take any point xy, it is x times 1, 0 plus y times 0, 1. Since this P point P is x times 1, 0 plus y times 0, 1. That's why any point x comma y can be written as x times 1, 0 plus y times 0, 1. As you change xy value scalars, you will get all the points. Okay. Hence, every point in this plane is expressed as a linear combination of these 2 points. A linear combination. Hence, every point on this depending on 2 points. 1 point and 2 points. Only 2 points. But this point is not depending on the other. That point is not depending on this. But every other point depending on this. Therefore, in this, among all these points, I have picked up 2 points which are mutually independent and every other point depending on this. Such a set is called basis. Such a set is called basis. Okay. Hence, what is basis? Basis consists of basis elements. This basis elements means they are the points which are independent, mutually independent, and they generate all other points in that plane or space. Hence, every other point P is a linear combination of these 2 points. Hence, if I say there is a basis for a space, every point in the space is expressible as a linear combination of the basis elements. And here, how many basis elements are there? I'm asking, what is the cardinality of the basis? Hence, cardinality of the basis is 2, hence 2-dimensional. Cardinality of the basis is 2 and hence 2-dimensional. Hence, dimensionality, it means cardinality of the basis. Hence, cardinality of the basis is called dimensionality. What is basis? I told basis is collection of independent elements where any element in the space is linear combination of the basis elements. These basis elements only independent. All other points are dependent on these basis. And such number of basis elements is called dimensionality. Nothing else. Hence, keep everything out in mind. Hence, dimensionality means for any given space of points, you have to find out what is the basis, how many basis elements are there. That number of basis elements is dimensionality. That is the point. Okay. Hence, now come on, tell me, what is the problem of dimensional reduction? Now, dimensional reduction means you have to try to find a new basis whose size of the basis is reduced. Size of the basis, cardinality of the basis means size of this basis. What is the size here? 2. Hence, you want to reduce the size of the basis. It means there may be one basis, you have to define another basis, but the new basis should have lesser size.
Excuse me, sir.
Yeah.
When you have plotted a line, you said that every point is coming onto that line. That means that it is a one dimension.
Hello?
Hello?
Yeah.
Earlier, sir, you have plotted a line and every point is there on that line. And then you have said that instead of 2 dimension, you can say that it is 1 dimension and you are creating your own dimension.
Yeah.
So that is what how you are decreasing the dimensions from 2 to 1. So
Yeah.
can you help me out that how you have reduced that, how I am retrieving all those points from that line and how I have created that one new dimension?
Yeah. Now, why you are so late? Today I have already told everything. No, again I have to go back. Yeah, fine. Yeah, yes, I told you There may be points which we have considered in a HW plane, height and weight plane. Since I am able to draw a new line covering all these points, I will forget about the standard axis and I consider the data as one dimensional. That is my claim. The one dimension which I have to draw is along the spread of the points. Hence, that also I told that where should I draw? I should draw along the spread of the points. And okay. Hence,
Yes, sir.
yeah. And that particular new line of action, new axis, that itself is your new one dimension, that is your new feature. Hence, in place of the given features H and W, I have created a new feature. Hence, I'm not going to take the given two features, but I'm constructing a new feature. Hence, feature construction has happened. That also I have got only one feature sufficient to represent the data points. Whether
So
data
what
point,
is bias over here? Basis over here. What is basis over here in case I want to calculate?
yeah, basis here is along this line, along this axis, any unit distance. This is the basis. Any unit distance. That's what. Since here, just now I was explaining the basis for this two-dimensional points is 1, 0 and 0, 1. This 1, 0, 0, 1 is nothing but what? Starting from this origin, it is only one vector stopping here, O to M. And similarly, another vector, ON. This is unit vector, this is unit vector. Hence, your 1, 0 is nothing but OM bar, in fact, OM cap, and this is also ON cap. Hence, OM cap and ON cap, which generally you are also writing as I cap, I bar, and J bar. And therefore, any point x comma y is x times OM, means xi bar plus yj bar. That's why you have OP x comma y, xi bar plus yj bar, or x times OM plus y times ON. These are all that what you have in the vector algebra, is it not? Hence, any basis point is nothing but the unit vector along the new axis. Hence, along this axis, the unit vector is 1, 0. That you can call it as I cap or j cap, whatever it may be. Ij doesn't matter for me. This 1, 0, it means it is the unit distance along the dimension. And along the another dimension, again I have taken a unit vector. Hence, unit vectors along the new axis are basis elements.
Got the point, sir.
Yeah.
Thank you, sir.
Right. Hence, basis element is nothing but unit vector along the axis. Right? Yeah. Now, now the discussion is quite simple. For a two-dimensional vector, two-dimensional plane, what are the basis elements? 1, 0, 0, 1. For three-dimensional plane, three-dimensional space, for three-dimensional space, three-dimensional space, what are the basis elements? What are the basis elements? 1 0
1 0
0
0
0 1 0 0 0 1. Is it not? Yeah. Hence now if I put them in this matrix form, hence now this is after all my unit matrix 3 by 3 I3 unit matrix, where my first row is one basis element, the second row is another basis element, third row is at another basis element. And each is representing a unit vector along the x-axis, y-axis, z-axis. I3. Hence it is now quite simple. If I have n-dimensional space, n-dimensional space, n-dimensional space, and thereby I will take, there are n features. Hence for one object, I am representing the feature values. It means, see here, I will give the values for each feature, say something v11, v12, so on, v1n. Hence I gave n values. This is an n-dimensional vector. This n-dimensional vector lies in n-dimensional space. I will take another object and its values also I will note down, v21, v22, so on, v2n. This is another n-dimensional vector. This is also a point in the n-dimensional space. Yes, therefore, when I give you a data D, which is the values of the features, particularly n feature space. N feature space means each object is mapped to a point in the n-dimensional space. Now, such an n-dimensional space will have the basis IN. IN is nothing but unit matrix of size n. Therefore, you know what is IN? 1 0 0 0. There will be n and another is 0 1 0 0 0, like this 0 0 1. This is n by n unit matrix. This is quite simple. And so far, what I have told is very trivial, that for a given n-dimensional space, the basis is IN. And for any given data, if there are n features, this definitely each is a point in the n-dimensional space, and that n-dimensional space has a basis of size how much? What is the basis of size? Basis of size n. That's why mostly your intuition is telling number of features, dimensionality of the space, and the basis size, all are same. All are same. Nothing wrong with your intuition. Now, with this understanding, that okay, I am given a data contains n features, therefore each is a point in the n-dimensional space. Any n-dimensional space will have the basis of size n. Hence, with this understanding, the problem of dimensional reduction is, though this is a standard default basis, hence this entire discussion what I am taking, I would like to call it as a default basis. Hence, no other basis, if it is given, this basis occurs. What is that? This unit matrix IM is the default basis for any n feature data set. Default basis. Default basis means what? Nothing else is given, this will be there. Hence, if no basis is given specially, this basis will be there always. Hence, for n feature space, for n feature data, IN is the default basis. But when you say default basis, is it possible to construct any other basis? Therefore, the problem of dimensionality reduction is investigating for a new basis other than this default basis. Hence, problem of dimensional reduction is investigation for a new basis of size m, possibly less than or equal to n. This n is anyway your n dimension, this n. Hence, you try to define a new basis of size m, and if you are lucky, m is less than m. If you are unlucky, m will be equal to m. Even in case m equal to m, sometimes you may get a better basis than the default basis. I have already shown that I have spread some the houses along this, but I have shown that those two roads are better than northeast and southwest roads, east west and north south roads. I have spread like this, is it not? Hence I have spread like this, and I have said that better you draw roads like this instead of drawing along the x-axis, y-axis. That's what I said. It's like that. Sometimes though m equal to n, the newly created basis may be the better choice than the original default basis. Hence, the whole thing what I would like to tell is, for any given data set, if there are n features, default basis will be there. But don't just satisfy with the default basis. You try to define a new basis. But how to define new basis is the discussion now. That is what we are going to do in PCA. Okay. Hence, we are always interested to investigate for a new basis, possibly smaller size. Possibly smaller size. If not possible, at least equal size you will get. Anyway, it will not increase your dimension. Okay, that is. Hence, now the dimensional reduction means in your mind, you should come that you are trying to reduce the dimensionality. You are trying to define the new basis of smaller size, because size of the basis is called dimensionality. If at least if problem is clear, then how to reduce all these things comes later. Hence, first of all, what is problem of dimensional reduction? It is investigating for a new basis rather than the default basis. New basis rather than the default basis. Default basis size is n. New basis size, if at all, if it is m, that m may be less than or equal to n. That's the question. That is the problem only. So far now I am telling only the problem and convincing that yeah, there may be solutions for this problem. Sometimes you may get a basis of smaller size that I have shown, 1 dimension, 2 dimension kind of thing, though I have taken 2 dimension, 3 dimension. Later, that's what. Now we have to think now, how do we define a new basis? Fundamentally, what do you mean by this a point expressing as a linear combination of the other? That already I told, but I will start there and then I will enter into how to define the new basis. Fine? Any doubt?
Sir, excuse me, sir. I have a simple doubt, sir. Sir, what is vector in this D data set, sir? Can we say features as vectors?
Yeah. Yeah, that also I have drawn just now. No, unfortunately the point is everything is known to you, but only problem is You are all thinking that this is a new subject, nothing to do with older subjects. I have already drawn this point, what you are telling. See, I have drawn a H and W, height and weight along the x-axis. I say that there is a fellow having 170 centimeter height and 75 kgs. Hence 170 comma 75. This is one H1 and W1. This is a point. Though he is a human being, I am mapping that human being to this H1, W1. Therefore, in my data set, there is a point called the P whose height is H1 and W1. This is my data. 2-dimensional height, weight. This I have drawn. And this H1, this P is 170 centimeters, I said. It means 1 centimeter is 1 unit. Hence, OM. This OM is multiplied 170 times. Hence 170 into OM bar, that is OM bar, plus 75 times OM bar. This OM plus MN, MP is equal to OP. Hence this point 170, 75, point won't lie like that. Always each point is connected to the origin. Hence here the vector is, the point P means it is a vector OP. Hence any point P which is having n values, this is n-dimensional. Why? N values. It is a vector. Yes, it is a 2-dimensional value. It's a 2-dimensional vector. OP bar. OP bar is equal to OM bar plus MP bar. OM up to here if you take. And each is a unit vector. I bar. 170 I bar and 75 J bar. Hence, each point is a vector. Vector connecting to the origin of the axis. Hence, each this set of n values, list of n values for this respective n features, each is a n-dimensional vector. Each is an n-dimensional vector. How many such n-dimensional vectors are there? Some 10,000 n-dimensional vectors are there. Therefore, each is a point in a n-dimensional space.
Okay.
Means anywhere in any space, point means point is a vector connecting to that. Point won't lie like that. Point is that. That's what I said. That's why any H1 W1 is H1 times 10 plus W1 times 01. That is what, this is what we call it as I bar. This is what we are calling it as J. Is it clear?
Yes, sir. Understood, sir.
Yeah. This is, see, our, now you recollect, this you have studied long back, maybe in 10th class or intermediate.
Yes, sir. So what are the mathematics subjects we need to study to
Nothing else.
learn?
Whatever you have studied, the sufficient. Only thing is you have to connect that to this.
Okay.
The teacher should connect. So again, now you cannot start from 9th class, 8th standard.
Yes, sir.
You have studied already. Only thing is the teachers know. At that time they don't know, they can't connect it. Now it is your effort
Yes, sir.
to connect these things.
Thank you,
Sir, I
sir.
have queries, sir, regarding principal component analysis and its loading. Sir, if
I'm yet to start. I'm only telling only the problem only I told so far. Yeah, tell me.
sir, basically, when we do some analysis with some of the water resources and all, generally some of the features are being loaded in PC1, PC2, and PC3. So some of the features are being some of the loadings, right? Some of the loadings are being on PC1, PC2, and PC3, but some are being shared between PC1 and PC2. In that case, what we need to consider, sir, if you want to feed this data into machine learning platform?
That's what, in fact, I have answered this question, but anyway, I will give again more clarity. That's right. The way I construct, all have in fact answered, but still let me again focus on it. Okay. Yeah. I have been using the word basis. What basis consists of? Basis elements. Basis elements will be there. Okay. There will be certain basis elements, certain number of elements will be there. If I take this data, which is containing n features, I said that there are these are the points in the n-dimensional space. The default basis is of size n. Of size n. What are those basis vectors? Basis vectors are 1 0 0 0 0 0 1 0 0. These are all I told you. Hence, this first one is this first one. Second one 0 1 0 0. This is your second. Like this, how many rows are there? This is IM, n by n, n rows and n elements. I am only thinking. Now, instead of writing 1 0 0 0 0 1 0, let me call this as let me give some names for this. That is, let me call it as alpha, beta. No, instead of that, let me call it as x1, x2. Again, that x1s will confuse. Let me call it as L1, L2, L3, like this. Hence, I am giving the names for each row. Hence, my L1, this entire first row, I will call it as L1. The second is L2, third is L3, and so on, Ln. There are n rows, L1, L2, L3, L. Fine. Since what is L1, you know, L2, L3, and so on. Thereby, I have default size basis. Now, when I said it is the basis, I hope you are not confusing. It is as simple as in the two-dimensional case. The two-dimensional case, we have a point x comma y. Any point x comma y is x times 1 0 plus y times 0 1. This 1 0 I have called it as L1. This 0 1 I have called it as L2. Therefore, any point is x times L1 plus y times L2. Or suppose if you say this is alpha 1 and alpha 2, and this is alpha 1 times of L1, alpha 2 times of L2. Hence, any point P here is expressible in terms of L1 and 2. Hence, what I am doing, alpha 1 L1, alpha 2 L2, so on alpha n Ln. Hence, the meaning of this default basis means for any p, there exists constant alpha 1, alpha 2, so on alpha n, such that p is equal to alpha 1 L1 plus alpha 2, so on alpha n Ln. Is it correct? Is it okay? First you agree.
Okay, sir.
Is it clear? Yeah. Any doubt? No, don't simply just for the sake of okay, don't say okay. You have understood this?
Yes,
It is
sir.
only generalization of 2-dimensional to n-dimensional. See, in 2-dimensional, you have alpha 1, alpha 2, the point. My point is alpha 1, alpha. Alpha 1 times of 1, 0, alpha 2 times of 0, 1. Instead of xy, I have written alpha 1, alpha 2. If you want, you can write xy. If you write xy, here also xy will be. But I can't write x, y, z like that. That's why I have chosen alpha 1. Is it clear for everyone? Yeah. Now, if you don't have any doubt, now I will proceed. And now your answer you will get automatically here. Now this is a default basis. This is default basis for the given data set. There are how many features are there? N features are there. This is default basis. And now you don't know how to find a new basis. Suppose someone came and gave you, this is the new basis. We'll tell anyway how to find new basis. But now at present, instead of this default basis, God has given you a new basis. The new basis is M1, M2. Okay. K1, K2, so on, Km. New basis, someone said that there are M vectors only. Here N vectors. Here N. Default basis is N. N features. Now there is a new basis of size M only. Of size M only. The basis vectors are K1, K2, Km. Now what is the meaning of this new basis? Means every point which was there in your data set, which you used to express as a linear combination of these default basis vectors, the same P will be expressed in terms of these basis vectors. Means there exists some beta 1, beta 2, beta 3 and so on, beta m, k. It means this P and this P same. Therefore, this equation 1 and this equation 2 both are equal. Both these expressions same or not? Same or not? This is the meaning of new basis. New basis means, I don't know how to construct, that is a different issue. Leave it. Morning someone was telling, if R and Python will do like that, PCS, suppose there is a tool that is give you K1, K2, Km. Now, since it is a new basis, every point should be expressed as a linear combination of these basis elements. It means same P is expressed as beta 1, K1, beta 2, K2, so on, beta m, Km. Therefore, this expression and this expression, both the equations are same, and both are the expressions for the same point P. This left side expression, this right side expression, and this right side expression, these two expressions are same. These two equations are same. Now, what happens? Here there are n components, and here only m components. N are there, here only m. Now, what would have happened? what would have happened? Whatever you said, no, your question only there. Now come on, repeat your question. In your water resources, what happened? Please repeat. Oh, quite frequently is leaving and joining. The person who asked about water resources, is he there? Jagdish Kumar? I think he is traveling. Yeah, just now he has left. See, for him only I am answering. Morning also he has left almost, and I am answering he has left. Maybe I think he is traveling. That's why whenever he opens.
Connection problem.
Yeah. Whenever he opens his that, no, it is creating sound.
He is somewhat Sandeep, someone name.
Not Sandeep, I think. Jagdish.
Jagadish.
Yeah, Jagdish. But this water resources person, Jagdish.
Yes, whoever asked for the dot, and is there or not?
Water resources person. Okay, anyway, this is true for everyone.
It's not there, sir, so not respond.
Yeah, just now he has left. Just he has. Now she has left the meeting. These are all very, in-depth concepts. People don't know much of this, but these are all very essentially should be delivered to the students. Otherwise, no. These fine details, they don't know. They are simply thinking that something is happening. Okay, anyway. Now convey the answer to him that, see what he was telling, his question was, certain features as it is they are mapping. This L1 may, if you look at, oh, yeah, my K1 is nothing but L1 only. Oh, hence L1 is there here also, but only name I gave, L1 equal to K1. Hence, if we say this L1, this height, suppose, this height is also height is there. Hence, some feature as it is getting mapped onto one principal component, sir, that's what he said. Yeah, L1 the same as K1. These two are matching. This L2 I will try. Nowhere it is. Oh, L2 is totally missing. L2 gone. L2 has gone. L1 has, as it is, it has come as K1. L2 try to locate, but it is not there. Hence L2 is totally missing. And some alpha 3 L3 plus alpha 4 L4, these two together, perhaps beta 2 K2. That's what he said. Some combination of two features will come as a new feature, sir. Yeah, it may come. This one small expression alpha 3 L3 plus alpha 4 L4, or maybe alpha 3 L3 and alpha 7 L7. Those two, the sum may become here as only beta 2 K2. Hence, K2 is not exactly there. But K2, this beta 2 K2 is the replacement for some expression in the older expression. Hence, if you compare these two expressions, these are the certain findings that you may feel. Something as it is there, something is totally missing, some portion is in fact, that is some combination of two basis vectors may be replaced by a new vector here. Like this, these new features are coming. This happens. That is what the new basis means. Okay. Hence now, I have told you what is the problem of dimensional reduction and what, in fact, new basis. What do you mean by expressing any point as a linear combination of basis elements? What happens inside? All these things I have shown you. You have understood. Only thing now left over is how to find a new basis. How to find new basis? That I have drawn in terms of geometrically. It is along the spread. But spread is not possible to catch if you have more features. Therefore, I started my discussion that how to find an analytical method equivalent to geometrical method. That is what we do in the PCA, where we calculate covariance matrix and then eigenvalues, and then we construct a matrix and then diagonalize it, and the number of diagonal elements, huge elements, that indicates the number of independent. This is all I have to teach, okay, which will take another 2 hours, and then we can display using some tool. That is also possible, okay. Hence, in PCA, why we are going for the covariance, why we are computing eigenvalues, eigenvectors, these are all we can have discussion. But it is time now. Yeah, 4:15.
Yes, sir. 4:15. Sir, we can wind up. We can
Yeah.
wind up. Okay.
Yeah.
Participants, still anybody have doubts?
Yeah, they will have definitely doubt, because now they are curious to know how a new basis is constructed, why we are calculating covariance, why what is covariance. That see, she was talking about correlation, why covariance comes here, and then why we are finding eigenvector, why not some other vector, what is that eigenvector speciality. These are all certain very fine mathematical points, very intuitively. When you are listening, no, oh, so much is there in this, then you will really appreciate your mathematics teachers. They taught all those things, but only thing is you don't know the value of eigenvector. Hence, how an eigenvector is different, is a speciality among the vectors. The rigidity of the vector, how it really, what is the main characteristic of the eigenvector. That if you know, then you will convince that why we are fixing the new axis along the eigenvector. Hence, you are fixing along the eigenvector. And similarly, why we study the covariance. It means when you want this independence nature, hence all those collinearity you have to strike off, remove it. That's what her intuition, Neetu Chauhan was telling. The independence, if you want to catch, no, that she was talking about the correlation, that we will go to the next layer, that is what we call covariance. And there we diagonalize it, and then we go for the this thing. And this PCA has roots in SVD, singular value decomposition. Hence, the mathematics, someone was asking what to study. Yes, lot of statistics you have to study, SVD, PCA, and this vector spaces, basis, all these things, linear algebra. These are all the parts which you have to revise. It's not the question of again doing some exercises. Nothing will help you in that manner. You have to really understand the true meaning of each and every word and technique. That's very much essential. Okay. With this comment, anyway, I stop here. I hope this theoretical discussion motivate at least some of you to do that rather than simply going away. Once if you have hold, no, then you can do some research, and then any tool, how it is working, it will be clear to you. Otherwise, we'll simply look at the tool and we see, we enjoy the dance, that's all. Nothing else. Yeah. No, and Kumar, okay now?
Yes, sir. Yes, sir. Participants, anyone to respond? Anyone to say? Anybody want to say anything about the session? Some comments are there. It is very beneficial when we have deep knowledge.
Sir, the session was really helpful and informative. Sir explained everything patiently. Thank you very much, sir.
Right. Welcome. Right. We'll see sometime. Yeah.
Sir explained concepts, basic concepts.
Our program.
Especially.
Now I would like to tell about our Electronics and ICT Academy.
Yes, sir. Yes.
Yeah, Electronics and ICT Academy. There are 7 academies in India. set up by the Ministry of Electronics and Information Technology. Our entire South NIT Warangal, here only this academy is there. I am the chief investigator. What we do, we have some fund given by the government of India. We use that fund, but at the same time, we have to generate some amount also. For any online FDP, if you want to conduct online FDP, you can drop a mail to us. In any area of computer science and electronics, and even other domains also, civil, mechanical kind of things also. The person who was asking water resources, there will be an FDP tomorrow in water resources highlighting the ICT. Since any branch of engineering, but there should be ICT component in that. Whereas in computer science and ECE, any topic okay for us. Here no restriction. But for other branches of engineering, or mathematics, sciences, anything, ICT component should be there. For online FDP, we charge rupees 750 for 40 hours lectures, 40 hours, daily 4 hours, 10 days, or 5 hours, 8 days, 750 rupees, 40 hours, 750 rupees, you can imagine, per hour only we are charging 20 rupees, less than 20 rupees, 750 rupees, but to organize this FDP, we have to pay resource persons, since we need not bother about it. If any institution would like to organize online FDP, send email to eict.nitw, eict.nitw@gmail.com. Send a mail to this, and you have to see that at least 50 participants gather. Since for 50 participants, you can imagine how much you will get. We will get only 37,500. But for each program, we spend nearly 1,15,000. That remaining amount, we take it from the project. Okay. If you want to organize any FDP, drop a mail to eict.nitw@gmail.com or to my personal email ID rbvs66. This project is only up to coming September. Up to September, in fact, March, they have extended finally. Up to September, people who are interested can send a mail to this.
Sir, some jurisdiction issues are there. Kerala, Tamil Nadu is not there, I think.
Nothing like that. Anywhere in India, particularly for entire South, ours is the only academy. Yes. Anywhere.
I also highlighted, sir.
Else. Only participants have to pay, each participant only 750 rupees. That's all. How to schedule, whom should be contact, resource persons, everything we fix it. Resource persons we have to pay 2,500 per hour. We will pay it. No, don't worry. That's what. Finally, we give the certificate, hard copy certificate will be posted to you. Any college can come forward to organize this.
Sure, sir. Thanks for your information, sir.
I also highlighted, sir, in the inauguration time, I told about this, electronics and ICT also.
Joining is very busy. Yeah.
Sorry, the director for that, but I highlighted.
Okay,
thank you very much, sir. Sir clearly explained the basics of the classification and decision tree based classification. Sir explained very neatly. We never forget about that decision tree based classification after listening this lecture. And very basic things clearly explained. Whatever the doubts we have, that clearly told. So that about that impurity and calculation of entropy, we have doubts. Now we are more clear about those concepts. And sir also cleared more about the dimensions, what is the dimension, and how to reduce it. Those basic concepts are explained very clearly. Not only computer science faculty, yeah, other faculty also can easily understand. That much neatly are explained. Thank you, sir. Thank you very much for spending your valuable time on behalf of the Department of Computer Science and on behalf of the participants. Our heartfelt thank you for your valuable time, sir. Thank you very much.
Right.
Thank you, sir. Thank you. Thank you. Participants, please fill the feedback form. All of you mute your mics, please. Manas posted na link.
Yes, sir. Yes, sir. Posted.
And we are also observing participants joining with a different names other than the registration name. So we are in confusion while summarizing the attendance. So anybody is joining with a different name, you have to inform it. And similarly, some names are coming in the shortcut form. Okay, that also we are not understanding. Those who are joining with a different names other than the registration name, please inform to me. Then only we can summarize your attendance correctly. Anybody joining with a different name? Manas link, feedback form link post again.
Sir, ECE NAC something is there.
But you have if that paper is there in your hand.
Yes, sir.
What is that name?
ECE NAC.
ECE is one name, na? NAC is another.
No, ECE NAC is single name.
Is somebody joined with ECE NAC? We don't know the name, exact name. So we are in confusion to summarize the names.
And also GVGK.
GVGK, na?
Yes, sir.
GVGK also another name.
And
this
some people are joining with a different mail ID, sir. That is not their name coming.
That's only.
That's also a problem. It's short form.
And all of you try to join with your registered mail ID. It has to display your registered name. Anybody joining with a different names, you have to inform me. Then we can do our attendance calculations correctly. I hope most of the members are leaving. Tomorrow morning we will remind you again. Manas will remain tomorrow morning. Now only 50 members are there.
Okay, sir. Okay.
Okay, thank you all. We'll meet again tomorrow. Okay, Manas.
Okay, sir.